the Higher Education Academy, HEA, Dr. Mikhail, continues to make significant contributions to academia and industry. Welcome once again, sir. We are honored to have you grace SPIN 2025. Now, I would request Dr. Mikhail to present on his topic, Autonomous Spectrum Awareness for Spectrum Innovation in Future Networks.
Good morning, everyone. Thank you very much for your kind introduction. Let me share my screen for my presentation. So is my screen, can my screen be seen? Yes?
Yes, sir.
Okay, thank you very much. So good morning, everyone. First of all, I would like to thank the organizers of the conference for inviting me to give this talk today. It's a great pleasure for me to have this opportunity to talk about my work. The title of my talk today is Autonomous Spectrum Awareness for Spectrum Innovation in Future Networks. The problem of spectrum awareness is basically about providing mechanisms to enable wireless communication networks to be aware of the activities that are going around there in their environment, so they can coexist with other wireless communication systems in an interference-free manner. So the radio frequency spectrum is the most valuable and important resource for any wireless communication system. All wireless communication systems need to be allocated some bandwidth so they can transmit and operate. That bandwidth can be in any of the many different frequency ranges that we are using nowadays, which is illustrated in this slide. On the lower side of the frequency spectrum, we have lower bands, usually below 1 gigahertz. These bands usually are characterized by very good propagation characteristics, so that means that we can provide relatively large coverage areas. But on the other side, the bandwidths available tend to be smaller, so that means that data rates tend to be low. More recently, current 5G communication systems and other systems, like for example, satellites and radars, usually operate in millimeter wave bands. So this includes from about 1 or 3 to 100, 300 gigahertz. In this case, the propagation characteristics are a bit more limited. They are more challenging. So that means that coverage distances are shorter. But on the good side, we can provide much higher data rates as a result of the higher bandwidth available there. And finally, we are recently considering in the community using much higher frequency bands in the terahertz domain in order to provide very high data rates in the order of gigabits per second for some modern or recent applications that require that very high data rates, in particular 6G networks and other similar applications. The downside of this spectrum is essentially a very challenging propagation environment that makes it very difficult to transmit the signals. So when it comes to deploying new wireless communication systems, we need some frequency allocated in one of these bands. Historically, legacy systems have been deployed mostly in the lower frequency bands. And what we have seen in the evolution of wireless communication systems is that as technology has evolved and new technologies have appeared, we have been allocating frequency bands in higher and higher spectrum, essentially because these frequency bands were allocated first, and as new systems appear, then we allocated higher frequency bands. So basically, that means that there is a trade-off between radio propagation characteristics and the amount of bandwidth and data rates that we can offer. Now, which band we use for our new system depends to a great extent on what spectrum is available, of course, and what are the characteristics of the system. So this slide shows the different features of bands at different frequency ranges. So basically, as I said before, if we go high in the spectrum domain, we can enjoy higher bandwidth and higher data rates, while on the lower frequency bands, we have lower data rates. Also, in higher frequencies, the spectrum propagation is more challenging, so that means that technology is going to be more complex, and there is a number of problems that need to be addressed, while usually propagation is more favorable on the lower frequency ranges. So based on that, in principle, if we have an application that requires a very high data rate, usually we would try to get some frequency in the higher domain because that is going to allow us to provide higher transmission speeds. But we need to understand that that is also going to reduce the coverage of our system. Some of the new applications that were introduced with 5G and that are also important in the context of 6G require very high level of reliability. So that means that in that case, probably high-frequency bands are not going to be a good option because they don't provide good propagation characteristics. And that means that we will need to somehow still use the legacy spectrum in the lower frequency bands. So that means that we need to coexist with those systems that were deployed here. As I said before, these bands were allocated historically first. So when we look at the frequency allocation bands of most countries, we will see that these frequencies are overcrowded and it is difficult to find any free spectrum. So in order to be able to exploit these frequency bands, we need to basically be able to coexist with those systems that have already been deployed there. That means that we need to understand how those systems are using the spectrum. So we need to be aware of the spectrum activity, and we need to use that in order to enable any new systems that are deployed in those bands to operate without causing interference to the existing systems. So in other words, we need to enable some spectrum coexistence or spectrum sharing if we want to reuse these frequency bands. The idea of spectrum sharing is not completely new. That has been around for quite a few years. We indeed have several technologies or standards. For example, the wireless regional area networks, that is one of the first standards for cognitive radio, and it is standardized in IEEE 802.22. We also have other technologies or sharing schemes like licensed shared access. Licensed shared access, authorized shared access, citizens broadband radio service. In 5G, we call new radio unlicensed access, which is basically the same system as was introduced for 4G that was called license assisted access. All these are frameworks that are designed basically to enable spectrum coexistence. In all these systems, we need essentially to enable our new communication systems to be aware of the spectrum activity of the legacy systems that are already deployed there. There are essentially two main approaches in order to enable that spectrum awareness. One of the first mechanisms that was introduced was based on geolocation databases. Here, the idea is that we have a database that contains information about spectrum allocations, spectrum use, and any other regulatory constraints that are applicable for the spectrum bands where we want to deploy our systems. When we need to make use of that spectrum, then we would query the physical location of the users, usually using some kind of positioning system like GPS, and then we would query the database to understand what is the frequency allocated and used in that region. This kind of a scheme has some pros and cons. So infrastructure complexity and cost is high because we need to deploy the infrastructure required for those databases. That requires around medium complexity for the new devices or terminals. Also, the compatibility with legacy systems is relatively low because that would require some changes to the legacy systems so they can integrate with these databases. But on the other hand, we have very high reliability because we obtain the information about the spectrum from the main spectrum users. One issue with this kind of approach is that they are not very dynamic. The issue with databases is that they are relatively slow. So we have an environment where spectrum dynamism is high. Probably databases are not a good approach because basically we need to retrieve the physical location of the user, send a query to the database, wait for the database to produce the response, and then receive that response. That mechanism is going to take some time, and sometimes by the time we get the information, it is already outdated and does not represent the actual state of the current spectrum. For that reason, there's a second approach that is based on spectrum sensing, or in other words, simply signal detection. The idea here is that the new system is going to monitor directly the spectrum use, and it's going to determine by itself how the spectrum is being used, and is going to obtain all the information required in an independent or autonomous manner. That means that the system will basically need to observe the spectrum activity, will use some signal detection algorithms to determine when other systems are making use of the spectrum or not, and then use that as the base information to obtain all other statistics and relevant information that could be exploited. An advantage is that the complexity and cost is low. We don't need any external infrastructure. All is going to be implemented in the new system. Also, that leads to high compatibility with legacy systems. The legacy systems will not be modified. In many cases, they will not even be aware of the other system being deployed along them. And these are suitable approaches for highly dynamic spectrum bands. So basically, the idea of autonomous spectrum awareness highly relies on the idea of spectrum sensing, where the new systems will be in charge of obtaining by themselves the information about the spectrum use. So the basic idea is that we have a legacy network that is already deployed in a frequency band. We want to deploy a new system in the same band. So basically, this system needs to be aware of the spectrum use of this other one. So the signal transmitted from the system is going to be monitored by the new one, and basically we are going to be looking at when the spectrum is on and off. So when basically the channels are being used by the legacy network. So we are going to deploy some spectrum sensing mechanisms to detect the activity, and we are going to store our outputs in a spectrum database that is going to be local to our new system. That spectrum sensing information can be processed both in real time in order to determine the instantaneous spectrum occupancy and make short-term decisions on whether they can transmit or not. But that can also be exploited to be analyzed in a longer term by calculating statistical information. Things like, for example, the minimum period durations, the average, the variance, or even the distribution that contains the full statistical information. So that information is going to be used for longer term decisions, like, for example, adjusting parameters of reading resource management algorithms and so on. So basically, we can produce information for the short term to make instantaneous occupancy decisions, and also in the long term to make spectrum occupancy statistics calculations that can be exploited in summary to improve the performance. Spectrum-aware systems can have different architectures, but most of them will follow an approach similar to this one. Basically, we are going to have a signal acquisition and spectrum analysis stage. So that is essentially the radio frequency end that is going to down convert the signal to the intermediate frequency, and there the signal is going to be sampled from analog to digital domain. We are going to calculate a spectrum or the Fourier transform to get the spectrum information. That data is going to be processed by a spectrum usage detection algorithm. So that is a spectrum sensing process where we use a signal detection mechanism. And this is what is going to provide the information used for short-term decisions. But we can also further exploit this information to calculate the statistics and develop some activity models that we can exploit in a longer term. So that is basically the architecture of a autonomous spectrum-aware system based on spectrum monitoring. So how do we estimate the spectrum activity statistics from sensing? The basic idea is that we have a frequency channel that is being used sometimes by the legacy network, and it's going to have some gaps where we can deploy our new system. We are going to be trying to estimate the duration of these periods, and to do that, we are going to be sensing the channel periodically every TS seconds. In each of these observations, we are going to make an hypothesis of whether the channel is free, hypothesis H0, or occupied, which is hypothesis H1. By looking at when these estimations change, for example, from busy to idle, or from idle to busy, we can determine some instance when there's a transition, and then we can estimate some durations of this period. So basically, these values here at the bottom are going to be estimations of the original periods on the top. So based on this sequence of periods, we can estimate the statistics, for example, the minimum value of these periods, the maximum, the average, the variance, any other moments that could be relevant, or ultimately the distribution, which will provide a full statistical characterization of those periods. That is going to give us information that we need, but we need to understand that we are going to have some limitations in the accuracy of the information we obtain in that way. One of the limitations is the fact that when we estimate the period durations using a finite sensing period, these periods are going to be integer multiples of the sensing period. So that is going to affect the accuracy. We can reduce the sensing period, but that is also going to require more energy. So there's a trade-off. Also, we are going to estimate our statistics based on a finite and limited number of observations. So that is going to affect as well the accuracy of our estimations. But most importantly, the main important factor is the presence of errors. When we have a signal with a high signal-to-noise ratio, probably we will not have any sensing errors or very few. But in most cases, we are going to be operating in moderate to low signal-to-noise ratio. And that means that sometimes our sensing algorithm is going to make some mistakes. So for example, if we have a false alarm here, we are going to observe this sequence of periods, which, as we can see, does not correspond to the original one. So even a single sensing error can introduce a significant different sequence of periods that is going to affect to a great extent our statistics. So the problem is how we can overcome the impact of these sensing errors in the accuracy of the statistics that we estimate. We can think of different approaches. In particular, we have been working on 3 types of approaches. The first one is based on algorithms to reconstruct the original periods. The second one is based on some mathematical models. And the final one is based on the use of artificial intelligence and deep learning methods. So the first one, I will just explain very quickly. The idea of reconstruction algorithms is to try to observe the sequence of periods that we have after our sensing, try to recognize potential errors and see how we can process that in order to reconstruct the original sequence. Imagine this is the sequence that we observed in our channel. Let's say that we know, for example, that the minimum period duration of the off and on periods is mu0 and mu1, and then we observe here 2 periods that are shorter than those minimum durations. We know that that is not possible, so we know that here there has been some kind of sensing error. So based on that knowledge, we can try to reconstruct the original sequence. For example, we can assume that here in point 1 we had a misdetection. So in that case, the original sequence would be something like this. But we can also think that in period 2, we had a false alarm. So that means that there's nothing here. And in that case, the original sequence will be something like that. So based on the knowledge of the minimum period duration and some other parameters, we can try to reconstruct the original periods. The problem is that that is not a perfect approach, because in some cases, the same sequence of observed periods can be the result of several original sequences, as we can see in this example. So that means that even if we can improve the accuracy, we are always going to have some amount of error in our estimation. So these methods can improve the accuracy, but they are not perfect. The second approach is based on mathematical modeling. We know that we have the original statistics of the original periods. Those transmissions have gone through the wireless channel. We have estimated those durations with some spectrum detection, and we obtain the observed statistics. The idea is that we develop some mathematical modeling, so we can express these observations as a function of the original ones and other relevant operation parameters like the sensing period, the probability of false alarm and misdetection and other errors, and the number of observed periods. Once we have obtained this mathematical model, we try to invert that model, so we can express this as a function of this by calculating the inverse of the model, and that will give us an estimation that hopefully should be closer to this parameter. So this parameter that here is shown as x can be the minimum period duration, the average, the variance, or the distribution. So that is a very high-level description, but that is the main approach that we have followed in some studies that you can find in the papers in this slide. And finally, the third approach is deep learning. This is a very popular approach recently. We know that artificial intelligence is a very powerful tool to address many problems, and that it can also be applied in this case. So we can train an artificial neural network with things like, for example, the original mean, the original variance, or even the individual periods in order to calculate the minimum period or even the distribution from a set of predefined options. So we can generate labeled data very easily with some spectrum occupancy models. Then we can split that into training, validation, and test data sets and use that to carry out our deep learning approach. So these are the 3 main approaches. I would like to show some results comparing these 3 methods. So in this figure, we are comparing the maximum absolute error of the estimated statistics, in this case, the average duration of the idle periods for the 3 approaches. What we can see here essentially is that the mathematical model tends to give us the highest error. That is because to obtain those mathematical models, usually we need to make some assumptions to make the model analytically tractable, and that results in some inaccuracies, as we can see here. The reconstruction algorithm gives a much better accuracy, but we can see here that the best accuracy is obtained with a deep learning approach. So in this case, this is for the average period, and this other figure is for the minimum period duration, which we can see that in the case of the deep learning approach is very, very accurate. So in all cases, essentially, the deep learning approach is going to give us the most accurate estimation. This is a similar result for the estimation of the distribution of the periods. Again, we have kind of similar trend. In this case, there is a lower difference between the mathematical model and the reconstruction algorithm, but still the deep learning approach gives us the best accuracy. Not only it gives us the best accuracy, but also has a lower computational cost. Well, if we look at the training time, that is usually going to be longer, but once we have trained our model, the execution time is going to be much shorter. So we can see here that we can run our deep learning models once it has been trained in a very short time. So that is not going to give us only better accuracy, but also in a lower computation time. So in summary, that means that deep learning approaches are the most promising ones. In this slide, the results were obtained with a simple multi-layer perceptron network. We can, of course, use more complex models like convolutional neural networks and other more sophisticated approaches, and hopefully we can expect better results. So that's something that needs to be investigated in more detail. That is just an illustration of some testing we did with some experimental equipment, some software-defined radios with an actual over-the-air transmission. And we evaluated the system to see how it converges over the time. So here we have the on and off transmissions. We set the threshold to detect the occupancy of the channel. We can see here, for example, the estimation of the average period, how it converges to the correct value after we have observed a sufficiently large number of periods. And here how the duty cycle of the channel also converges to the right value. This is an estimation of the distribution, which we can see is relatively accurate. So that means that this kind of approach can actually work very well in real systems. One last point I would like to highlight is the application of this kind of estimation approaches in real systems. One possible application would be the coexistence of mobile communication systems with Wi-Fi systems in unlicensed bands. The main issue here is that we need to ensure that the mobile system coexists in a fair way with a Wi-Fi system. Basically, a fair coexistence means that when we deploy the mobile access point, that should not degrade the performance of the existing Wi-Fi network by more than it will be done by another Wi-Fi access point. So that reference case where we have Wi-Fi networks is on here in the red bar in terms of the Wi-Fi throughput, and that is the disruption that will be caused by another Wi-Fi access system. We can see that the coexistence mechanism provided by 3GPP does not meet that requirement. That is basically because the coexistence protocol does not adjust the parameters of the protocol based on the activity statistics. So we decided that we could use these estimation methods that I have presented before to obtain an estimation of those statistics, and that could be used to tune accordingly the parameters of the coexistence protocol. So that means that we can optimize those parameters based on the actual activity statistics that we have estimated previously based on those methods. When we do that, we can observe that actually the performance can improve significantly. We can, for example, adjust the waiting time by a fixed value that is calculated according to the on and off periods of the Wi-Fi network, or we can also adjust the transmission opportunity time based on those statistics as well. In both cases, we can see that we can obtain performance improvements. For example, in the case of the Wi-Fi throughput, if we use the fixed waiting time, we can provide a much higher throughput at the reference case at the expense of a lower aggregate throughput for both networks. So if we want to ensure fairness, that would be the actual best approach, the fixed waiting time. But if we want to ensure that we optimize the overall performance, in that case, we'll be looking at the aggregated throughput. And in this case, another approach that adjusted the transmission opportunity time according to the statistics will be more appropriate. We can see here that the aggregate throughput between both the Wi-Fi and the mobile network would be higher in that case. So depending on which is the priority for our system, we see that we can develop coexistence mechanisms whose parameters can be adjusted or tuned to be optimized according to the activity statistics. And we can therefore exploit these estimation methods to practical applications, as we can see in this example. So that's all from my side. Thank you very much for your attention. If there are any questions, I will be happy to answer. Any questions?
For such an informative session.
Okay, thank you very much.
Now I invite Ms. Shikha Bhatia to present a certificate to Dr. Mitchell as a token of our appreciation.
Thank you so much, sir.
Thank you very much.
Thank you once again.
Yeah, thank you very much. Very nice to present my work. Thank you.
Thank you, sir.
Everyone, please patiently wait till Dr. Ashish Mathur joins this session.
Hi, hello, good afternoon.
Good afternoon, sir.
Afternoon, sir.
Good afternoon, ma'am.
How are you, sir?
All well, thank you.
So we'll be starting in a minute or two.
Sure.
It is our great privilege to have Dr. Ashish Mathur with us today. I would like to call upon Mishika Batla to present a sapling to Dr. Ashish Mathur.
Welcome, sir.
Thank you so much, ma'am. Thank you.
Dr. Ashish Mathur is a professor at the University of Petroleum and Energy Studies in Dehradun, India. Dr. Mathur is deeply committed to improving healthcare accessibility and affordability by developing innovative, low-cost, and profitable sensor technologies. His work focuses on bridging the gap between advanced laboratory research and real-world healthcare applications, making diagnostics more efficient and accessible and impactful, especially in resource-limited settings. Dr. Ashish Mathur's research is distinguished by robust quantitative achievements and innovative breakthroughs in sensor technologies. His scholarly output includes over 120 publications in high impact journals, garnering an H index of 24 and more than 2,000 citations, which underscores his influence of his work. Notably, his research on point of care diagnostics has led to the development of sensors with linear detection ranges. These efforts have resulted in 26 Indian patents and alongside accolades such as the GST UK Award and INSA Young Scientist Fellowship. With a passion for innovation and societal impact, Dr. Mathur's contributions continue to reshape healthcare delivery and sensor technology, ensuring cutting edge solutions reach those who need the most. Welcome once again, sir. Sir, would you like to call to upon the paper presenters, or would you prefer if I did it? So would you like to call upon the paper presenters, or would you prefer if I did it?
Sorry, say that again. I would like to call.
Upon the paper presenters, or would you prefer if I did it?
Yeah, you can start that session. Thank you.
Okay, sir. Now I would like to call presenter from the paper ID 40 to present their paper. Kindly show your valid ID for the verification.
Hello.
Yes, ma'am. Could you show your ID for verification?
Actually, my webcam is not working right now. How should I prove you my ID?
No issues. You can send a pic in the chat box. You can check there.
I am joining through my laptop, so
Uh,
I
can
currently
send
don't have my picture ready with me.
you don't have your phone with you, right?
No, right now I don't have.
Okay, first, okay, you can present after the session. Before the session gets over, please let us know about situation.
Okay,
You can share.
sure.
Please switch on your camera.
As I already said, I'm having issues with my webcam, so I cannot turn on my web.
Okay, we can continue.
Should I present my screen?
Yes.
Is my screen visible to all? Hello?
Yes, it is visible. Please continue.
Okay, thank you. Good afternoon, everyone. Thank you for being here today. My name is Nehal Aidi. I'm here to present our research paper titled Sustainable UAV-Assisted Data Collection in Wireless Sensor Networks Using Renewable Energy and Wireless Charging Platforms. This work was constructed in collaboration with my colleagues at the Department of Computer Science and Engineering at Heritage Institute of Technology, Kolkata, and at National Institute of Technology, Agartala. Today, I will walk you through our research objectives, methodology, key findings, and future directions. Abstract. Our research addresses a critical challenge in wireless sensor networks, the limited flight endurance and the energy inefficiency of unmanned aerial vehicles or UAVs used for data collection. To tackle this, we propose a model that integrates solar power as a primary energy source and wireless power transfer or WPT as a backup recharging solution. Our approach optimizes energy consumption, ensuring sustained data collection even under varying environmental conditions like wind speed, sensor density, and altitude. Through simulations, we achieved extended UV endurance, reduced energy consumption, and efficient data collection, making this a promising solution for long-term WSN applications. Coming on to the introduction, wireless sensor networks consist of numerous sensor nodes that collect and transmit data for applications like environmental monitoring, traffic management, and disaster prevention. However, UAVs face significant challenges in these scenarios. Direct communication with sensor nodes is highly energy intensive, and UAVs have limited flight endurance due to onboard power constraints. Traditional solutions like battery replacement or recharging are inefficient and unsustainable. To address this, we propose integrating renewable energy sources like solar power and wireless charging platforms to enhance UAV endurance and energy efficiency. Our model ensures efficient data collection by reducing reliance on conventional batteries. Contribution. Our research makes several key contributions. Firstly, we innovatively integrate solar power and wireless power transfer to extend UAV endurance in WSNs. Second, We optimize energy consumption by reducing reliance on conventional batteries, ensuring sustained data collection. Thirdly, we evaluate our model under varying environmental conditions such as wind speed, sensor density, and altitude, demonstrating its adaptability and efficiency. Real-time decision-making module for evaluating the current battery level and proximity to cluster heads and charging stations determines the best steps for the UAV, enhancing operational efficiency and sustainability. These contributions make our model a robust solution for long-term UAV-based WSN applications. Now we come to the related work. Before going into our proposed model, let us briefly review the related work. Several studies have explored renewable energy integration in UAVs. For instance, solar power UAVs have been designed for long duration flights in sunny regions, but they struggle in cloudy or nighttime conditions. Wireless power transfer WPT has also been explored, with some studies achieving up to 75% efficiency in UAVs recharging. However, these approaches often lack in often face limitations in range and alignment. Our work builds on these studies by combining solar power and WPT to create a more resilient and efficient energy management system for UAVs. Now we come to our proposed model. Proposed model begins with an initialization phase where the UAV's position, battery level, and energy parameters are set. Sensor nodes are grouped into clusters using a clustering algorithm, and the UAV identifies the next unvisited cluster head. If the UAV's battery level is sufficient, it proceeds to collect data. If not, it recharges at the nearest WPT station using solar power or WPT depending on current environmental conditions. This process continues until all clusters are covered and the UAV returns to the base station via the shortest path, ensuring efficient energy use. This is the workflow of a proposed model, and the key benefits of this model include optimized energy management for prolonged UAV endurance and efficient coverage of sensor nodes for comprehensive WSN data collection. The working principle of a model revolves around energy optimization and data collection efficiency. The UAV starts with the initial battery level and monitors energy parameters like solar energy harvested, energy consumed during flight, and energy recharge via WPT. Sensor nodes are grouped into clusters, and the UAV calculates the shortest path to each cluster head to minimize energy consumption. If the battery level drops below a threshold, the UAV recharges at the nearest WPT station. This ensures continuous operation and efficient data collection. During the data collection process, the UAV hovers over a cluster, gathers data, and calculates energy consumption based on the data size, transfer rate, and hovering time. The total energy required by the UAV for collecting data for the next cluster head is the sum of the energies required by it to move to the next distance between itself and the cluster head and for hovering. The current battery level then would be the battery level before moving to the cluster head plus the solar energy gained minus the energy consumed during its journey. If the battery level drops below the threshold, the UAV navigates to the nearest WPT station, recharges, and then resumes its mission. The deficit in battery level is calculated as the current battery level minus the solar energy harvested. Once all the clusters are covered, the UAV computes the shortest return path to the base station to optimize energy usage. Results and discussions. Our model was implemented and evaluated in a simulated environment using a 10 by 10 grid with 5 sensor nodes and 2 WPT stations in Google Colab. We used Q-learning for UAV movement and decision making. Key factors affecting performance included UAV speed, altitude, communication range, and environmental conditions like wind speed and sensor density. Our results show that centralized cluster head placement reduces energy consumption, while random placement leads to inefficiencies. Additionally, favorable wind conditions and optimal altitude significantly improve UAV performance. The figure on the right-hand side displays how the UAV is successfully able to complete its mission by visiting every cluster head and returning back to its space station. On the right-hand side, we have several graphs showing the outcomes of a simulated flight, and we have derived several key insights from it. Favorable wind conditions allow the UAV to cover more clusters with lower energy consumption and in significantly lesser time. Higher sensor density increases hovering time and communication load, while altitude variations impact the trade-off between communication range and energy consumption. Our model's energy and battery utilization trends demonstrate its efficiency across different mission stages. Compared to the conventional UAV models, our approach shows superior performance in terms of reduced energy consumption and extended flight duration. Here are the points related to the outcomes of the simulations as we have already discussed. Conclusion and future scope. In conclusion, our proposed UAV-assisted data collection model efficiently addresses the challenges of energy consumption and mission efficiency in WSNs. By integrating solar power and WPT, we ensure prolonged UAV operations with reduced dependency on conventional batteries. Our clustering approach minimizes travel distance and optimizes data collection efficiency. Future work could explore advanced energy harvesting techniques like hydrogen fuel cells, improved WPT technology, and machine learning integration for real-time path optimization. Additionally, autonomous UAV swarms will be investigated for scalable WSN deployments. Finally, I would like to acknowledge the foundational work that inspired our research. Some key references include studies on solar power UAVs, wireless power transfer systems, and energy-efficient UAV designs. These works have significantly contributed to the development of our model. Thank you for your attention, and I am happy to take any questions you may have.
Hello, Sneha, can you hear me?
Yes, sir.
Yes. So thank you very much. It was a very good talk. In this model, do you have any validation of this proposed model? Do you use any specific, how do you validate your model, whether it's working as per the data?
Sir, actually, we have made our data set and we have run tests on them.
But in that data set, do you have, or are you considering the effect of temperature? Because with the effect of temperature, the battery powers will be different. In older region, it will be different. In much hotter region, it will be different. So are you considering that in your model?
Actually, we have focused mainly on the wind speed, altitude, and sensor density. Because it is difficult to simulate so much data with such parameters.
I understand, but this is an important parameter for battery efficiency.
Yes, sir, definitely.
Okay. And do you have any estimation of cost in terms, if you want a real-time experiment, if you want to perform, how much it will cost to implement your model in existing UAVs?
Sir, this totally depends on the areas where we will be applying this model. Like if it's a large-scale project, then it will take a huge amount of budget.
But do you have any quantification?
Right now, I don't have exact approximation.
Okay. Okay. Thank you so much.
Thank you, sir. Any more questions do you have?
No more questions from my side. Thank you.
Thank you, sir.
Thank you so much. Now, I would like to call presenter from the paper ID 73 to present the paper. Kindly show your ID for verification.
Thank you, ma'am. This is the ID.
Yes. Thank you. Kindly continue with your presentation.
are my slides visible?
Yes, it is visible. Please continue.
A very good afternoon, dignitaries and the participants present over here. I am Kankanjyoti Kalita, a 8th semester BTech in Electrical Engineering, then from Assam Engineering College, Guwahati, Assam, India. First of all, I would like to thank the organizers of SPIN 2025 and the dignitaries present here for giving me this wonderful opportunity to present my research work. Next, I also want to thank the co-authors, namely Ankur Thakuria, Junta Burman, Smita Saharia, and Dr. Midusmita Sharma ma'am for their valuable contribution towards this work. So with this, I would like to start my presentation. So the efficiency of solar photovoltaic systems depends mainly on how effectively it is able to capture sunlight. Traditional solar tracking systems adjust the tilt of the solar panels solely based on the position of the sun, but they neglect other environmental factors such as humidity, global horizontal irradiance GHI, temperature, etc. Now, in our research, we have used machine learning technique to find the optimal tilt angle for the solar panel based on the various environmental factors. Furthermore, we have also implemented maximum power point tracking (MPPT) to ensure the efficient power delivery to the load irrespective of the changing environmental conditions. So moving on to the site selection and dataset. The dataset used in our research was obtained from National Renewable Energy Laboratory, NREL's National Solar Radiation Database, NSRDB. Now this data is location specific, which corresponds to the Assam Engineering College, Guwahati. Here we have used 6 environmental parameters. They are the month, day, hour of the day, temperature, relative humidity, and the GHI, global horizontal irradiance. So this diagram shows our methodology of our research. First of all, we have done the data collection. As mentioned earlier, we have gathered the historical solar radiation data from NSRDB. Secondly, we have done data pre-processing. Here we have handled missing values, normalizing features, and we have done correlation analysis on the data. Third is machine learning model development. We have trained a feed-forward neural network FNN and random forest RF model to predict the optimal tilt angle dynamically. Next is MPPT implementation. Here we have implemented maximum power point tracking algorithm to ensure that the PV panel operates continuously in its maximum power point. And finally, we have done simulation and testing to evaluate our system. This block diagram shows our gives an overview of our system. First of all, environmental data is collected and fed to the machine learning model, which predicts an optimal tilt angle. Then this tilt angle can be given to the control mechanism of the solar panel to optimize the sunlight capture. Simultaneously, we have used an MPPT converter, the MOSFET. Of the MOSFET. Next is prediction model training. We have explored 2 machine learning models for predicting the optimal tilt angle. These are feed-forward neural network FNN, which is a deep learning approach. Here we have used 6 neurons in the input layer, and in the output layer we have 1 neuron, which is a tilt angle. There are four hidden layers which construct the nonlinear relationships between the input layer and the output layer. Next, we have used the random forest algorithm. Here we have used 100 decision trees, and each decision tree is chained to make an individual prediction. And finally, we have averaged them to get a final prediction of the tilt angle. Next, moving on to the MPPT simulation. This was done in MATLAB Simulink. Here, after maximizing the solar power generation from the solar panel, here within this circuit, we have ensured that the load is getting the maximum power from the solar PV system. Here, we have used perturb and observe algorithm to control the duty cycle of this MOSFET of this boost converter, which regulates the voltage and the current, and thus allow the system to continuously operate at the MPP. Next is the result and discussions. To evaluate the model's effectiveness, we have compared FNN and RF model on two performance matrices. These are mean squared error and mean absolute error. From this table, we can clearly see the feed-forward neural network performed much better in accurately predicting the optimal tilt angle, which is indicated by its lower mean squared error of 2.91 as compared to 7.04 of the random forest model. But one thing we can see that the random forest model performed very well in terms of the compositional time, which is only 5.5 seconds in comparison to the 113.6 seconds of FNN model. This graph shows the performance of the FNN model. Here, we have plotted the actual versus the predicted tilt angle. See that the results exhibit a strong correlation. And in the second diagram, this is the training and the validation curve. From this, we can see that the model is successfully converging, and the mean square error is getting minimized over time. Next is the performance of the RF model. We have plotted the predicted versus the actual tilt angle. This red line is the ideal fit. So we can see that the RF model is also giving us satisfactory results in determining the optimal tilt angle. This is other simulation results of the MPPT circuit. Here, the PP power is a generated power which is coming around 1 kilowatt, and this is the
Sorry to interrupt. However, due to time constraint, I would like to request you to kindly wind up in 2 minutes.
Okay, ma'am. So this graph is the load delivered to the power delivered to load, which is also nearly 1 kilowatt. So this suggests a successful operation of the MPPT. So to conclude our presentation, I would like to summarize our research focus on developing smart solar tracking system and also combining machine learning and MPPT to improve solar energy efficiency. Our key findings were that the FNN model performed much better compared to the RF model in optimizing the panel tilt. And the second was the MPPT circuit successfully optimized the power delivered to the load. In future, we can expand our research work by using more sophisticated machine learning models as well as larger datasets. I would like to thank these references for their previous work, which was very helpful in our research. And with this, I would like to conclude my presentation, and I welcome any questions on your side. Thank you.
Thank you for the presentation. You mentioned that your model considered sun position, right?
Yes, sir.
So is that can the receptor change its angle uh, it's in operation, or is it only in the prediction model?
Yes, sir. If we implement this in the hardware project, it will definitely be operational like that.
Okay. And do you have any intensity sensor incorporation plan as well? That sometimes, sun intensity also vary with the time.
Sir, yes, sir. For that, which is the global horizontal radiance GHI, it is the amount of solar radiation falling on the panel. For that, sir, we can use the pyranometer, which gives us the solar radiation.
Okay. Okay. Thank you.
Thank you so much, sir.
Thank you so much. Now, I would like to call presenter from the paper ID 91 to present their paper. Kindly show your ID for verification.
Hello, am I audible?
Yes, ma'am. Ma'am, kindly show your ID for verification.
Wait a minute. Huh? Is it visible? Or I should upload it after the presentation?
Ma'am, could you please upload your ID in the chat?
I will upload it after the presentation. Is it fine?
Okay. Thank you, ma'am. Please continue with your presentation.
Okay, thank you. Thank you all. Good afternoon, all. This is I am going to present my paper that is based on modernizing and validating safety products. These are the authors. Let me put it in the presentation mode first. Yes. And I'm Neha Agarwal, who is going to present this paper. So modernizing and validating safety products. So development of sophisticated facial recognition system is essential for enhancing security and safety and security in our technological advanced society, because nowadays we know that CCTV cameras or video-based surveillance is everywhere. So we want to develop a system that can accurately, efficiently overall improve the safety standard without the need of any additional system for the safety measurements. So here where basic aim is to provide the safety in any kind of industry, and wherever we want to provide any restricted environment or we want to provide any safety measures, we want to use this system. So our system is basically divided into three parts. First, we are doing smoke and fire detection. Second, trespassing, and third, it is safety gear detection. So what our basic aims is to upgrade facial detection algorithm or object detection algorithm. We want to use modern object detection algorithm and machine learning algorithm. Primary purpose of this is to transfer the security protocol, providing holistic security system that proactively detect and address potential risk. So goal is to create the any inconspicuous way of noticing safety breaches. So basically we have three parts: fire and smoke detection. In fire and smoke detection, already we know that ionization based sensors are available, but the problem with those sensors is that they can produce false alarm, and second thing is they can alert only when there is any fire that has already happened. So we want a proactive solution instead of reactive solution. So fire smoke detection sensor can only trigger an alarm when fire has already taken place. What we want that we should be able to inform before that fire outbreaks. So here, with the help of CCTV surveillance, we'll try to capture the image of fire and smoke, and we'll try to find out if there is any chance of fire, early detection of fires. Okay? So with the help of that, we'll try to provide early alarms. So traditional method, as I already say, ionization and photoelectric are already aware, but they have the limitation that they can generate false alarm, and as I say, that they can generate alarm only when the fire has already outbreak. But we want any and early warning, and for that we are using video-based detection system. Where for what we are going to generate heat maps and smoke image recognition. If we are able to recognize these images early, then we can produce early warning alarm to the admin so that they can take the reactive corresponding actions. And here we have also used CNN based YOLO V8 model to improve fire and smoke identification. So for traditional system was cost effective, but as I say, they lead to the false alarm. And here we are improving the accuracy for image detection and heat maps using vision based system. Trespassing detection is another thing. There we have fancy security patrol, but they do not guarantee real time monitoring. We cannot do real time monitoring all the time. But as you know, that video surveillance is now available everywhere, but they have also certain limitation like users' private details and low light conditions. So here we want to develop a trespassing detection system where we can work in low light conditions, and also it should work 24/7. So if any unauthorized user or an unauthorized person is trying to uh, access any inaccessible area, so it should generate an alarm, real time alarm to the admin so that they can take corresponding action. So we CCTV based AI CCTV, we are using CCTV with AI based motion detection, enhancing the real time security. And aquatic sensor we can also use, but with what is the problem with aquatic sensor, that they can detect any unusual sound pattern as then trespassing. So if there is any surrounding there where there are not any sound disturbances, where there we can use acoustic sensor as well, but in all the condition we cannot use that. So next is safety gate detection. We know that it's a construction site and some of the industries that safety gear is very important. So we want safety gate detection algorithm so that if a particular worker is not fulfilling any of the safety gear measure, there are we have find out the 11 to 12 parameters that they should be wear before going on the construction site. If worker is not following that, or work, because most of the time workers take it very lightly that if they do not wear helmet or safety gear and some gloves, and it is okay for them. But from the industry point of view, we want to provide a system that should provide an alert to the admin if the worker is not following those protocols and they are not wearing that safety gear properly. So here what we are doing, we are real time, again we are doing real time monitoring on of the construction site. If any worker we found that he is not wearing the helmet or mask or vest in the workplace, we are going to provide the real time alert. Real time alert will go to the admin as well, and at the same time we are going to pick a buzzer on the construction site as well, so that workers are aware that they are not following some of the protocols. Again, it is again to provide an early warning and to reduce down the safety measures. So here we are using, in this paper, we are using AI and variable sensor to improve the accuracy. But because of the resource constraint, here we have all used only the AI-based system. We are not able to implement sensor. But yes, if we are going to take both things into account, we can improve this accuracy further. So in system architecture, basically what we'll do, we are going to give CCTV feeds to the server on real time basis, and this feed will go from these 3 of our algorithms that we have implemented, like trespassing detection, safety gear detection, and fire and smoke detection algorithm, and it will convert a real time alert, and that alert will goes to the admin.
Excuse me, ma'am.
Yes, ma'am.
Sorry for the interruption, but could you please wind it up in
Yes,
3 minutes?
definitely.
Thank you.
Yeah. Conversion CNN for fire and smoke detection we have used, and YOLO, you only look once, YOLO V5 version 5, 7, and 8 for real-time object detection. And these are some of the Python libraries that are used in our system. And for training data set for fire and smoke detection, we have used DFire dataset with over 1,000 images. And for safety gears detection, we have used RoboFlow dataset that is also with somewhat 18,000 images. These are the results. These are some of the models we have implemented with. For fire detection, the performance, as you can see, that YOLO V8 is giving the best accuracy among best of the models because of the precision and the frame, that concentrated frame that it is able to capture. And for smoke detection also, that YOLO V8 is giving us the best accuracy that is approximately close to 95%. As I say, we can improve this accuracy further with the help of some IoT based sensors. But yes, because of, as I say, because of the resource constraint, we are not able to implement it in this particular paper. But yes, with the help of YOLO V8 sensor, we can enhance this accuracy further. In conclusion, I would like to say facial recognition revolutionize safety and security across the various sectors by shifting from reactive to proactive risk detection. This is the, as I said, the basic aim is we want the sector from reactive to proactive detection so that we can mitigate the chances of the risk. Its exceptional accuracy and efficiency enable real-time detection for the fire hazards, safety breaches, and unauthorized access. Future enhancements, as I already said, that we want to use enhanced sensors technology for more accurate and reliable safety product and IoT connectivity for real-time monitoring and recognition. That's it from my end. If there is any further question, I'm open for.
Hello, ma'am. Thank you for your talk. Do you have data for any real-time experiments? Have you performed any experiment on this hypothesis?
Actually, we have we try to collaborate with some of the industry person, and but they do not allow the direct access to their data set. But we have given them our system. They have uploaded their data set to produce that alert, and according to them, that it is working fine with the accuracy that we have provided. It is giving the similar kind of accuracy for their data set.
Okay. Okay, ma'am. Thank you.
Thank you, sir. Any further question?
Shikha, ma'am, you want to ask any?
No, sir. No questions. Apurva, please continue.
Thank you so much. Now, I would like to call presenter from the paper ID 157 present their paper. Kindly show your ID for verification as well.
Please show your ID card. You're not audible. Okay. Please continue. You're not audible. Nikhil, you're not audible.
Is it audible now?
Yes, please continue.
Okay. Should I start again, ma'am? Okay. Hello, panel. This is Nikhil Narayan Kapitkar from KLE Technological University, formerly known as BUP. And I'm a final year student from EC department. And my project for today, project title for today is Simulation and Analysis of Voltage Mode Control Buck Converter for Energy Harvesting Applications. So initially, the main reason for us to the purpose which driven us to start with this buck converter was like we had supposedly we had to design uh, like we were innovating a computer mouse powered by an piezoelectric material that functions as a clicking mechanism. Like the piezoelectric material was responsible for charging the mouse. So the like to achieve the efficient energy management, the voltage controlled buck converter was integrated with additional few circuits cold start circuit, MPPT, LDO, and these were the four circuits which were integrated together to form the prepare the circuit of the mouse, and the components work together to ensure seamless and reliable operation of the mouse, eliminating external power sources or battery requirements. So I'll start with the introduction of the buck converter. So basically, a buck converter is nothing but a circuit which steps down the voltage, the input voltage. Why is it named as buck is because there is an inductor in the circuit which works against the charging. Like when the input voltage is charging the inductor, right, it resists the current flow and produces its own voltage, which will resist, which in turn acts against the input voltage. So hence the step down is done with the help of the inductor. It employs a series of switches an inductor and a capacitor to regulate the output voltage by adjusting the duty cycle of the switches. Basically, the entire this is a open loop buck converter, which is just an example. The real which we during the starting initial phase of our exploration for the research for the EHPM Energy Harvesting Power Management ICs, which was basically meant for designing the mouse, was started with this. So these are the literature surveys, like we had gone through these papers and for the basic design of what a buck converter does and what all components have been required and what are the blocks necessary for it. These are the parameters for specifications of what a buck converter we had designed, wherein the input voltage what we were supplying was 2.5 volt and we are getting an output of 1.5 volt and 50 milliamps. This was a requirement based upon the mouse because the circuit
we are taking the input from a circuit output of MPPT. So it is providing an output of 2.5 volt. We had to drop that voltage to 1.5 volt. So hence we start make the buck converter like this. So the efficiency and switching frequency are thus follows. So this is an open loop buck converter. Basically, as I explained, it just like bucks the voltage. That is that it drops the voltage down. Since there is no feedback, so output voltage varies. Load and input changes in the sense that the voltage output will be dependent upon the input voltage. So there are many parameters. If in case the input voltage is varying, the output won't stay stable. Even it might vary. The input voltage and the output voltage remain fairly constant, reducing the need for dynamic adjustments. In the sense, since there is no feedback circuit, there has to be a dynamic adjustment being done in the switch, which is basically a PMOS. Further ahead, this is the circuit what we have been working on. This is the voltage mode buck converter. What we work. It has been like it is voltage mode control in the sense that we are generating a pulse signal which is dependent upon and varied upon based upon the output voltage. So the feedback mechanism does the thing. The feedback mechanism continuously compares the output voltage to the reference voltage to ensure that the output remains stable and regulated regardless of changes in the input voltage or load conditions. The LMC is acting as a low pass filter, which regulates the stability of the output voltage by removing the ripples noise. And next, the inductor resists, as I said, inductor resists a sudden change in the current, while capacitor resists a sudden change in the voltage, collectively reducing the ripple. So the feedback controller circuit is nothing but a type 2 compensator network circuit, wherein we have employed a 7-pack op-amp. Basically, the two resistors from which are providing the feedback, RF1 and RF2, create a voltage divider to generate a feedback signal, that is VFP, which is directly proportional to the output voltage. This feedback is given to the stable reference, which is compared with the stable reference what we have provided, that is a 1.5 volt, because that is the output which was required. So the output voltage, what is being fed back to the compensator circuit, is being compared to that data amplifier is having another signal, that is the reference signal, which is of 1.5 volt. It compares it with it. So basically, there were options of choosing type 1 compensator, type 2 compensator, as well as type 3 compensator. So we went on with type 2 compensator because the type 1 compensator had basically a single zero, which was not sufficient for the phase margin and gain margin requirement, and for the boosting of the voltage. Boosting of the phase margin. So we went, the second two options were type 2 and type 3 compensator, but type 3 is very dynamic and it's like very high transitions are being going on. So we needed something which is moderate and which stands in between type 1 and type 2. So we went on along with type 2. So basically FLC, FESR, F0 and FSW are the frequencies which are being like checked upon. These are the kind of parameters, kind of frequencies are considered as the parameters for which we were designing the entire circuit. The FLC is a natural resonant frequency, that is a low pass filter. So the ESR is as I previously showed, there is a resistor, ESR, which is basically adding a zero, which will help to stabilize this. It's like a series resistance which is being added to the capacitor, which introduces a zero in the circuit, in the transfer function. So this is the purpose of the resistor ESR. F0 is a desired crossover frequency, and the crossover frequency is maintained at a frequency lower than that of switching frequency. That is half of switching frequency. Okay, the pulse width this is a PWM generator, pulse width modulator generator, which is a RAM generator. The RAM generator is basically a sawtooth or a triangular waveform generator, which is in sync with the clock signal. So what it does is basically it synchronizes with the clock signal and generates a ramp, which is used for this is the main signal which helps in setting the switching frequency, which is then later on helps in driving the gate switch. Uh, the RAM signal is then compared to the error signal in the comparator to generate the switching signal. The synchronization with the switching frequency guarantees the RAM signal corresponds to the converter's operational cycle, giving precise control over the duty cycle. So in short, this RAM signal, whatever the signal is being generated, is the main reason for controlling the duty cycle. So the PWM generator is the comparator circuit wherein the input from the error amplifier, which is a compensator to type 2 compensator, the signal, which is a control signal, which is then compared with the RAM signal. This comparator is the one which is doing the comparison. As you can see in the results, in the green waves are the signals which are being compared. The lower side of the signal is then used as for turning on it, and the vice versa is for if the signal reaches above the RAM signal is above the control signal, then there is a turn off, the switch turns off. So this generates a duty cycle of turning on and off. This is a pulse. By modulating the duty cycle based on the feedback loop, the PWM generator ensures that the output voltage remains stable and matches the desired reference voltage, even with varying input voltage or loading conditions. The PWM generator gate driver. So the gate driver is basically a circuit which amplifies the signal, because after the signals are being processed by the comparator and the type 2 compensator and all, we'll get a signal which is very low powered. So yes.
Sorry to interrupt. However, due to time constraint, I would like to request you to kindly wind up in another 2 minutes. Thank you.
Okay. Okay. So the gate driver, and the gate driver is designed such that every this is a series of inverter circuits when every proceeding inverter is having its W by L ratio doubled, because the current requirement for driving the gate of the switching switch is more. So hence we are amplifying the signal. Also, it's also generating a dead time, because since there are two MOSFETs, that is, one is a PMOS and NMOS, there has to be a lag between that. Which is called as dead time, for preventing the overlap and reducing the switching loss, in the sense the current is the input voltage is drained directly to the ground if both are turned on simultaneously. So these are the results. As you can see that the mark what we were requiring was 1.5 volt. So we are almost reaching to the same results, 1.56, and the current requirement was 50 milliamps, which we are reaching up to 53.8. So conclusion of finding demonstrates that the voltage mode control is highly effective for maintaining the cell output voltage despite varying load and input conditions. That is why we had used a feedback controlled voltage per converter rather than an open loop voltage control. Implementation of type 2 compensator meticulously turned to ensure both stability and transient response was crucial. And these are the results. These are the references what we have referred to, around 11 papers. Due to some space concerns, I had just mentioned 8 of those. But that is all. Thank you. I'm open for questions.
Hi, Nikhil. Thanks for your presentation. Can you define the comparator? How do you define comparator? What does it do?
So a comparator is basically a circuit which takes two signals as an input, which since there is one reference signal and another is the control signal, as in my circuit, it just compares and generates a signal which is modulated based on the inputs. So as in for my comparator, it's generating a pulse width modulated signal, which is dependent upon the clock period. It's like generating a switching frequency duty cycle.
How does it work actually? What is the working mechanism? Or Or can you tell me the working mechanism of an op-amp? I saw in one of your circuit there was an
Yes,
op-amp. How does it work?
there's this. Okay, sir. Sir, I shall show you the I'll explain with the circuit itself.
Yeah.
So this is a 7-pack op-amp wherein there is a differential input here, V plus and V minus what we are taking in. There is why the reason behind using two like NMOSes on either side was to increase the width because of some limitations in our simulations tools what we are using. We had a limitation and for which we had to add two MOSFETs on the either side as an input. So after to increase the length. So above which there are P1 and P2, which is a current mirror, which is acting as a active current source load to the differential input signals. And there is a MOSFET as an N6, NMOS, which is providing the source I reference current, which has been provided to this. The P1 is mirroring the current on P2, which is keeping both the sides of this like the differential input signals on this stable ground. Like since the W by L ratios are same, the only thing which was requiring for them to be on equal terms was providing equal currents. So hence we have current. This operational is just like a 5-pack op-amp. The next second stage, why is it called a 7-pack? Because the second stage amplification is done by P3, which is acting as a common source amplifier. So basically N5, N6 and N7 is also a current mirror, which is providing as an active current source load for this P3. So there is 2-stage amplification. First at the input stage wherein input stage where there is a differential input and then there is a common source amplifier.
Okay, thank you.
Thank you, sir.
Thank you so much. Now, I would like to call presenter from the paper ID 256 to present their paper. Kindly show your ID for verification.
Yeah, just 1 second. Just give me 1 minute. Right, so it's on my phone. Is that I don't think it's visible. I can show you my office ID card if that's all right.
Okay, please continue.
Right. Let me share my screen. Is it visible?
Yes, please.
Okay. Okay, great. So good afternoon, everyone. My name is Reba Qureshi, and today I'll be presenting our paper Q-Learning and Deep Deterministic Policy Gradient Method for Energy Optimization in HVAC Systems. I would also like to mention the other authors, Manu Sharma, Dr. Divika Kumar, Shivam Kotalia, and Vijayanti Sambat Kumar. So just to give an overall summary of what we have done in this paper is we have tried to optimize the use of energy in commercial buildings using reinforcement learning. So some of the most popular methods in reinforcement learning are Q-learning and DDPG, which we have tried to implement for the optimization of energy. Usually reinforcement learning is used for game playing mostly, but this is one unique approach that we thought would be great for optimizing energy. So we have built a custom OpenAI gym environment for simulating a building and its parameters. And our results show that DDPG has a better performance with a steady increase in rewards. And, this can be really used to reduce the energy consumption in buildings. So why exactly are we doing this? It's because, as we all know, global warming, climate change, these are all really big issues. And commercial buildings contribute to about 25% of carbon dioxide emissions. Also, by the next 30 years, the energy consumption is expected to increase by 50%. So this calls for a need of optimization for sustainability. And we cannot just say stop using less energy because we also need to drive advancement in technology. So for that, we have turned to reinforcement learning.
Now, what exactly is reinforcement learning? It's a method in which there is an environment. That environment can have various states, and we can take different actions to reach those states. And there is an agent which will explore the environment. It will go to all of these different states by taking different actions, and there will be one reward function. So the agent will try to maximize the amount of reward. So how it would work in an HVAC system is that we could define a reward function in such a way so that it optimizes the use of energy as well as maximizing the comfort of people. So that's exactly what we have done here. Here are some of the papers we went through in the literature review. We have reviewed about 27 papers, but these are the major ones that contain all of the technologies that we came across. So the most common is Q learning. So the disadvantage of Q learning is that it's really simplistic. It's very easy to implement, but the disadvantage is that it's built for discrete action spaces. So if we only wanted to go up or down or left or right, it's just these 4 options. In that case, Q learning would be a good option. But in HVAC systems where it's dynamic, there can be a lot of various, it's a continuous action space. The temperatures can go up and down by any quantity. So for that case, Q learning or any variant of Q learning, even if it's deep Q learning or dwelling deep Q learning, that is not a good option. Another thing that we came across is multi-agent reinforcement learning. So that's, again, another option that we could have gone for. But the disadvantage is that it's mostly suited for decentralized systems. And our goal right now here is to do it on an individual and single basis. And applying multi-agent reinforcement learning for a single building would be too inefficient use of resources. So that's why we have tried to balance the performance as well as the resources that go into it. So that's where we come to our proposed methodology. We have used OpenAI Gym for building a custom environment that simulates a building. It has a bunch of parameters like the temperature, humidity, the size of the floor, the number of people on a specific floor, and all of these factors that define the state of a building at that specific time. So we have used Q learning and DDPG and tried to do a comparison of how they perform. One challenge with reinforcement learning is that we don't have any accuracy metrics like accuracy or F1 score. So we cannot say this has a higher accuracy, so this is a better method. We have rewards. So how rewards work is that there's a reward function and it can be different for any system. So we cannot compare rewards of different methodologies and say that, okay, the higher reward is the better method, but we can observe the progression of those rewards. And by that progression, we can observe which method performs better. So here is an overview of our methodology. First, we built the environment using OpenAI Gym with the building temperature, the humidity, outdoor temperature, and all of those parameters. Then we initialized our DDPG agent. So the agent is the being that will explore the environment and try to maximize the reward. So this DDPG agent has an actor network, a critic network, and a memory buffer. Now I will go into the structure of this in the next slide. But what happens is the actor will generate an action. It will analyze what state we are at. And from that state, what is the best action? It will try to do that. The critic will take the action and it will analyze it. It will try to sort of test if it's a good action or not. And with that, the action will be taken. Again, this will be a kind of cycle until the maximum reward is reached or until a specific number of iterations. And with each iteration, the actor and critic networks will get updated. And there is also a memory buffer which stores all of these states and rewards. And the network will randomly sample some of these events to kind of generalize and use the past data. So this is how a DDPG network is built. So there is an actor and a critic. So I'll start with the actor. In the middle, we have the evaluate policy network. So this is the main network. It will try to evaluate the current policy, the current rules we are following, and it will try to generate an action on the basis of that, on the basis of a current policy. Now, this target policy network is a copy of this evaluate policy network, but it has frozen parameters which will get updated after a certain number of iterations. So this is there to introduce stability so that there is not a lot of fluctuations and not a lot of small increases and decreases, which will kind of make the system unstable. And the Adam optimizer here is used to optimize the network that's evaluating and generating these actions. And similarly, in the critic, we have a similar method in which there is a evaluate queue network and there's a target network again with those frozen parameters. But the purpose of critic is to evaluate the actions of the actor. And all of these things will be getting stored in the experience replay memory, which is used to just use the information, use the rewards from the past states to decide what state we should go to next or what action we should take next. So coming to the rewards, this is the reward table of Q-learning. Now, again, as I mentioned, we cannot evaluate the performance of a method just by evaluating the reward itself, but we can evaluate its progression. So we can see in Q-learning, it starts from minus 4,000 and ends up as minus 1,300, which is not a lot of improvement. But in DDPG, it starts from minus 73,000 and it reduces up to minus 1.28. Now, this minus is not really a metric of how good or bad this is, but we can see that in DDPG, there is a huge change and a huge increase in the reward. So if we try to see the graph, we can see that in Q-learning, it's kind of erratic. It's not, there is no recognizable pattern in the rewards, but in DDPG, there is a steep increasing curve. And after that, it stabilizes. So it has converged, it has reached the maximum reward. And so we can really see that DDPG is the obviously better option here. This is also one graph we generated to compare the energy consumption in Q-learning and DDPG. So what happens in Q-learning is that it decreases steeply for the first few iterations. But after that, it's not really, there's no recognizable pattern. It's very erratic, it's very unstable, and we don't want instability in our system. Meanwhile, in DDPG, there is a more recognizable downward pattern. It's decreasing with time and it's less erratic and it's more stable. So that's why we have come to the conclusion that DDPG is a better approach and it can really be used to revolutionize the use of energy in buildings. And as I said, global warming, these are issues that we really need to focus on. So DDPG also has a bunch of different parameters, hyperparameters that can be used for fine-tuning it and increasing its performance, like the learning rate, the discount factor, and the noise. So one thing I didn't mention before is that this DDPG also has a component called the Ornstein-Erlenbeck noise. So this noise is used to introduce generalization into the system so that it does not just learn one specific system and then perform bad on the other new systems. So that noise is also something we can tweak a bit, and that's something we are working on, tweaking these different parameters to improve the performance. And here are our references. We had 27 references, but I've just included 20 in this PPT. And that's all from my side. Thank you, and I'm open to questions.
Riba, thank you. It's a very good talk. In your model, are you predicting or are you considering the off-grid, on-grid, solar, everything, or is it?
Okay, so so what we have done is we have not taken the actual blueprint of a building. We have tried to build our own model. So for this is our initial research, the initial progress of our research. So we have included very simple building parameters only regarding the temperature. And that is something that we are definitely looking into include in our simulation and make it a more realistic model of a building.
Yeah, then it will be a complete package actually if you incorporate those.
Yes, sure. We're looking into that.
Sure. All the best. Thank you.
Thank you.
Thank you so much. Now, I would like to call presenter from the paper ID 341 to present their paper. Kindly show your valid ID for verification. Thank you.
Purva, how many presenters do we have now?
Sir, this is the last presenter.
Okay. Okay.
Paper ID 341. Raja Subhasri M. Thesis font.
Ma'am, I'm sharing the screen, ma'am.
Okay. Please show your ID card first.
Yes, ma'am.
Please share your screen. Paper ID 341.
My screen is visible, ma'am.
I think it's stuck. Please share again. Please share your screen. I think she has a network connection. We can wait for 1 or 2 minutes. I think you can rejoin. This can help.
Okay, ma'am. I presented as a next batch, ma'am.
What?
Next, ma'am, it's not showing that screen, ma'am. Just give 2 to 5 minutes, ma'am. I will share the screen, ma'am.
Please
I'm
do
trying
fast
for
as
that.
you
It
are
is
the
not
last presenter.
connected. It's saying that it's not supported from like that. It's saying, ma'am. That's why.
You can join
Just
via
one-
your phone. it is possible.
Rejoin, ma'am.
Okay, rejoin. Everyone, please wait for 2 or 3 minutes.
Eka ma'am, how do I give these scores to you?
Yes, sir.
The scores for the presentation, I've given the marks as well.
You can, I just call you. Ashish sir, you can send the scores to Shubhra ma'am.
Okay, ma'am.
Okay, sir.
Thank you.
I think paper ID 341 is not joined.
Ma'am, can you confirm the first paper ID, the first speaker, solar power one, UAV plus solar power?
Yes, so the paper ID is 440. Paper ID is 40. And paper presenter is Neha Lahiri.
Okay. 4040, right?
40, right?
Okay, ma'am. Thank you.
I would request you to wait for 2 to 3 minutes.
Shikha ma'am, can I leave now? Or should we wait for this?
So she's trying to join, but I
Yeah,
don't
okay.
what is the problem?
No problem.
Her network connection is very weak.
Okay, no
She's
worries.
trying again and again, but we can wait for 1 or 2 minutes, then we can conclude.
हाँ ठीक है, 2 o'clock I have another meeting, so I can wait for 5 minutes. No problem.
Okay, sir.
Okay.
Thank you.
Due to internet connectivity issue, our last paper presenter was not able to join us. I would like to thank each paper presenter who presented their paper on their hard work. It was really a fruitful experience. I would now request Ms. Shikha Batla to present Dr. Ashish Mathur a certificate as a token of our appreciation for being the session chair. Thank you so much, sir. Your presence has really lifted the entire session's experience.
Thank you once again, sir, for being a part of our event. And we look forward to see you soon again. Thank you once again.
Paper presenters who presented their paper will receive their certificates via email shortly. I would like to now request Dr. Ashish Mathur to give us permission to close the session. It's been a privilege to have you all today and make this session a success. We thank you, Dr. Ashish Mathur, once again to take some time out of your valuable schedule and be a part of SPIN 2025. Thank you for being a part of SPIN 2025. We will resume the next session at 2:15.
Sorry मैम, मेरा नेटवर्क चला गया था. कुछ anything? Any update? Purva, is there an update from the speaker?
Sir, our last paper presenter will not be able to join us due to internet issues.
Okay, no problem. No problem. So, are we done for the day?
Thank you, Ashish, sir. Can we close the session?
Sure, please. Thank you.
Yes, sir. Thank you once again.
It was a very nice session and few talks were really interesting. And congratulations for the successful event. And you and your team, all volunteers, very well done. Thank you.
Thank you, sir.
Thank you for being a part of SPIN 2025. We will resume with the next session at 2:15.
we are just waiting for one or two guests to join. And all other participants and attendees have joined through a different platform. They are not visible here, but they are hearing to you.
A very good afternoon to one and all. I, Abhiraj Singh, on behalf of Department of Electronics and Communication Engineering, Amity School of Engineering and Technology, Amity, Uttar Pradesh, feel honored to welcome you all on the first day of the 12th International Signal Processing and Integrated Networks Conference, SPIN 2025. I also wish to extend a warm welcome to all the delegates and the paper presenters present here. It is a great privilege to have Dr. Peter H. J. Chong with us today. I would like to invite Ms. Shikha Batla to present a sapling to Dr. H. J. Chong.
Should I start my presentation?
We welcome you, sir.
Professor Peter Han Ju Chong is the Associate Head of School at the School of Engineering, Computer and Mathematical Sciences, Auckland University of Technology, New Zealand. Between 2016 and 2021, he was the Head of Department of Electrical and Electronics Engineering at AUT. He received the B Engineering in Electrical Engineering from Technical University of Nova Scotia, Canada in 1993, and the MASc and PhD degrees in Electrical and Computer Engineering from the University of British Columbia, Canada, in 1996 and 2000, respectively. He has visited Tohoku University, Japan, as a visiting scientist from 2010 and Chinese University of Hong Kong, between 2011 and 2012. He is currently an adjunct professor at the Department of Information Engineering, CUHK. He is a fellow of the Institution of Engineering and Technology, UK. Before joining AUT in 2016, Professor Chong was an associate professor from July 2009 to April 2016 and assistant professor from May 2002 to June 2009 at the School of Electrical and Electronic Engineering, Nanyang Technical University, Singapore. Between 2011 and 2013, he was the assistant head of division of communication engineering. Between 2013 and 2016, he was the director of Infinitus, Center for Infocom Technology. He was the recipient of EEE Teaching Excellence Award and Nanyang Award Excellence in Teaching in 2010 and Nanyang Education Award in 2015. Welcome again, sir. We are honored to have you grace in SPIN 2025. Now I would like to request Dr. Peter H. J. Chong to present on his topic, FAQ, a fuzzy logic assisted learning model for resource allocation in 6G V2X.
So much for your kind introduction. Okay, so let me share my screen with you first. Are you able to see my screen?
Yes, sir.
Okay, good. Yeah. So, okay, let me start. Okay. First of all, I'd like to thank the SPIN Conference Committee for Amity University to invite me to give a talk for the conference today. So this is my pleasure to be here to present some of my recent research finding to all of you. Hopefully you are able to gain some knowledge or some new thing from me today. So the topic today will be a FAQ, a Fuzzy Logic Assistant Q learning for resource allocation in 6G V2X. So that work actually was mainly done by previous PhD student, Dr. Ming Long Zhang. And the result, most of the material for this talk actually has been published in this IEEE Internet of Things journal in 2023. So in case some of the things are not so clear due to the limited time, you may be able to refer this paper to more detail in order to help you for your future research. Okay, so let me start. So again, this research mainly focused on V2X. In case some of you may not be familiar with this term, so let me give you a very short overview of this one. V2X actually stands for Vehicle to Anything. It's a smart mobility technology for vehicular communication network. So that one actually mainly based on wireless mobile communication and networking technologies. The aim actually is to enable vehicle to communicate to other vehicle or access point along the road. So a vehicle basically will utilize their onboard communication tools to provide this real-time traffic update, respond to the changing condition, and recognizing the roadside warning and more. So in brief, V2X actually aim to get the vehicles to talk to each other. So there are few different V2X communication mode. One of them is called V2V, vehicle-to-vehicle communication. So under this V2V communication, each of that vehicle need to install a device we call the roadside unit. So the roadside unit will be installed inside the car. So you can consider this just a Wi-Fi for car or car Wi-Fi. So if these two cars are within the communication range, they're able to send data to each other. However, in some scenario, the two vehicles may be far away from each other. In that case, we need to use another communication mode called the V2I, vehicle to infrastructure communication. So what it does, some of the infrastructure, for example, traffic light, street lamp posts, they may install another car Wi-Fi device, which is called RSU, roadside unit. So that these two cars will be able to communicate through this roadside unit attached to the traffic light. This is another scenario under V2I. Another communication mode is called V2P, vehicle to pedestrian communication. So some of our smartphone already has this car Wi-Fi chipset, so that the car will be able to communicate directly to a mobile phone. One scenario is that, for example, if the car is about to cross the zebra road, then this car will send this warning message to all the pedestrians so that they will be able to pay attention about the traffic situation. So in brief, this kind of communication network we can call VIP networks. Okay, so this is the basic understanding of the V2X. So now about this research. So with the rapid increase of this AV, autonomous vehicle, in the near future, we're expecting that a huge amount of data communication by different digital device and application will be required. So to address the limitation of the current 5G, to support V2X communication, the future 6G cellular communication introduced many new techniques such as AI, machine learning, terahertz communication, UAV, and intelligent reflecting surface in order to accommodate this massive data communication in the future. So many advancements in the 6G V2X actually very rely on this fine-grained and intelligent resource allocation for the physical layer resource. So the 4G, 5G, 6G, the physical resources will be based on OFDMA in the two in terms of the time and frequency resources, as you can see in the diagram. So we have the x-axis, which is the time domain divided into different subframe of 1 millisecond. And on the frequency domain, we will divide this into different resource block. So the data from the user equipment will be sent over the data channel, and the other the control channel will carry the control information we call the SCI, silent control information. So the SCI contains the detail for receiving the data, such as what subchannel to be used and what kind of modulation and coding scheme to be used, and other additional information as well. So for this research, what are the motivation? As a result, for this research, we try to propose a new way of the intelligent resource allocation we call a fuzzy logic assistant reinforcement learning model. In short, we call FAQ. So this FAQ basically will try to integrate two different AI technique, fuzzy logic and the Q learning. The idea for the fuzzy logic aim is to accelerate the learning. At the same time, we are able to use the Q learning to do the long-term refine of the resource allocation. So this combination of the fuzzy logic and Q learning will be able to explore the limited resources in order to satisfy the stringent requirement for the V2X requirement for 6G, such as low latency, ultra reliability, and high data rate. So our proposed FAQ not only can ensure the QoS for different V2X application, but we also have another advantage for the faster convergence in learning compared to other machine learning based resource allocations. The good scalability and able to apply to the regular network for different V2X service. So the main contribution of this one will be, first, we propose a novel resource allocation to combine fuzzy logic and also Q learning to maximize the network throughput. Second, we compare to other advanced learning, the benefit of this FAQ not only have a faster convergency, but also outperform other resource allocation scheme in terms of throughput and the packet delivery ratio. And we also develop a analytical model to analyze the network throughput. And we have built a comprehensive simulation model under this urban environment to look at the system performance and try to validate the mathematical model as well. So that is our network model. So this is a centralized mode that the resource allocation decision is made by the base station. So the base station will be allocate the resource in terms of resource block based on the request from the UE. So in the UE, in our model, we have two types of user equipment. One is a VUE, vehicle user equipment, and also we have the roadside unit. As I mentioned, the roadside unit will be attached to some of the switch infrastructure, such as traffic light. We also have another communication device called the cellular UE, which is just a normal pedestrian with the cellular phone. So whenever the base station requests some resource allocation request from the vehicle, the base station can decline a transmission if the base station is not able to find a suitable resource block within the transmission window. And also, under this V2X communication with two radio interface. One is a UU, the other one is a PC-PHY. So the UU interface is the cellular interface to support the communication between the vehicle and the base station. Another PC-PHY is to support the direct V2X or V2V communication. So this is our problem formulation. The aim of this resource allocation is to maximize the network throughput by assigning this resource block to different UE in the network. For example, we assume we have M UE, and each of the UE can obtain, let's say, from the R subchannel. So we first define the resource allocation matrix X. So the Xij indicate the J subchannel allocated to this ith UE. So the Xij can be 1 if that particular channel is allocated to the UEI, otherwise that will be 0. So the idea we like to maximize the throughput. The throughput, we have defined 3 different types of throughput, which is the high, medium, and low priority services in the network. So the optimization problem will be to optimize the throughput of these 3 different priority services. And subject to the throughput for the high priority should be higher than the medium priority services and then higher than the low priority services. So that is the whole architecture of our proposed FAQ learning model. So first of all, we have the transmission request from one UE that like to request for the resource. So inside that will be action selector. So that action selector, as I mentioned, is to integrate of 2 AI model, fuzzy logic and also the Q-learning. So the fuzzy logic is under a fuzzy logic learning model called the FUSRA. And this FUSRA will try to make use of the 4 different input, based on the 4 different input variables in order to make the decision to select the resource block based on timing, interference, mutual reception, and the priority. Another resource allocation decision will be made by this app is the E-greedy technique based on the Q-learning formulation. So later I will tell about this Q-learning more detail. So after that, the action selector will try to select the resource to allocate to that request from one of these model, from the FUSRA or from the Q-learning. So once this decision has been made to select the resource block to allocate to the request, then after that, we will go to that reward calculation. And then that reward calculation will see whether that kind of resource allocation will give a better or poor performance. And that kind of reward calculation will go into the Q table to update all the action space in order for the future selection. And then after the Q table, we'll go to the action policy adjustment in order to change some of the action space in order to make the decision from the Q-learning to select the resource block. So again, this is an overview of that FAQ learning model. So later I will spend a bit more time to look at the Q-learning part. So under that FUSRA, actually that is one of the research we have published in 2021. So that have the detail about that fuzzy logic process to make the decision of the resource allocation based on this input variable. Since I present this before in the SPIN, so here I will not spend the time to talk about the FUSRA, so I will directly go into the Q-learning about the greedy selection. So in case some of you want to know more about how the fuzzy logic can help to make the decision of the resource selection, then you can refer to this paper to have more detail. So now today I only focus on the Q-learning on the second selection AI model. So for the Q-learning part, first of all, with the initialization, then we in the beginning of the network, how to make the decision to select the resource block since the network has the Q table is empty in the very beginning. So that is very important and useful. We first use the fuzzy logic approach to obtain an initial resource allocation for all requests sent by different UE in the same allocation session. Then once with this one, that will be the basic the foundation for us to adjust the Q-learning table. Then after that, we can employ the Q-learning to improve the initial allocation. So then after the initialization, we have the Q-learning state. So we try to formulate the state S, which is the resource allocation at the time T, based on vector description to describe the existing resource allocation for the T transmission. So that is the typical, this is the Q-learning state formulation derived by us. So in that formula, the xt-1 represent resource allocation for all the requests after t-1 time of the adjustment, assuming that that has been allocated t- times already for the resource. So that xt-1 will summarize the entire sequence of all the past adjustment. So for sure, x0 refer to the initial resource allocation for the request using the fuzzy logic. Another parameter is the CT star that represent the conflicting zone of the vehicle when we try to allocate the T request by that equation. Another will be the throughput, high priority, medium priority, and low priority, and the gamma represent the successful allocation for these three types of the priority of the services. So that is the state we define for the resource allocation to all the requests. So next will be the action space, how or where we can try to allocate the resource to the user. So the action here will be indicate the base station, how the base station try to adjust the sub-channel and sub-frame allocation of a request. So under the OFDMA, were many resource block, but however, we are not trying to allocate each resource block to the user. Normally, we try to allocate the sub-channel to the user. And in this research, we have each sub-channel with 5 resource blocks. So when we allocate the resource, we allocate at least the sub-channel to the vehicle. So how many sub-channel we allocate to the request depending on what type of services. You look at the table 2, the priority factor. For example, if you look at the cooperative maneuver, which is we consider as service 2, that one has a high priority. And for this one, we'll be allocating 10 sub-channel. Remember, each sub-channel has 5 resource blocks. So depending on the service they request, then we will allocate certain number of sub-channel. So these are the 6 services we have considered in our study. So in our model, there are 7 possible successive sub-channel choice for 20 subframe. So in that case, the total actions space will be 7 possible sub-channel choices times 20 subframe, and that would be 140 different action space. So one frame, normally one frame in 4G, 5G, 6G with 20 subframe. Each subframe will be 1 millisecond. So So that would be the possible action space you can see in the diagram. For example, under surface 1. So you look at the priority factor, the surface 1 refer to the cooperative awareness, and that will be allocate 3 subchannel. So when you look at this one, every time we allocate the resource to the surface 1, we need to allocate 3 subchannel. So we can allocate 1, 2, 3. If 1, 2, 3 are not available, then we can allocate 4, 5, 6. And if not available, we can allocate 7, 8, 9. And each of these subframe has a total of 22 subchannel. So in that case, under surface 1, there will be 7 possible subchannel allocation, such as 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 19, 20, and 21, 7 different subchannel. So for different surface, we have different subchannel allocation possibility. Next, we go to the reward. So again, the aim is this one is to optimize the throughput, which is combination of the high priority, medium priority, and low priority. So that is the optimization we like to reward after the subchannel has been defined, has been selected. And once we have the reward, then we like to do the Q-learning update. So in the learning phase, the base station will adjust the resource allocation to have the better network performance. So the equation you saw, that is the Q-learning update formula. So in this formula, we like to update the current resource selection, which is the ST and AT, and that would depending on the 2 action space. One is the current one, QST80. The other one will be the QST plus 1A. So the other one is the future Q table learning update. Yes.
Sorry to interrupt you, sir. I'm sure all participants are enjoying your talk. However, due to time constraint, I would like to request you to wind up in another.
Okay, okay. So I think that's too long for me to describe that one. Okay, let me a few more minutes. So, okay, so I think that was too much for me to spend. Okay, maybe I just show you some of the result. Okay, it's too long. So okay, so first of all, a few more minutes. So I like to look at the network throughput for our FAQ model compared to other Q learning model. One is the FASTRA, Q learning, and DQN. So one of the things I like to indicate is the stability. So if you look at this one, after the 9 episode, our FAQ become more stable. However, if you look at other, let's say the Q learning and the DQN, if after even 9 or 11 episode, they are still not able to have the stabilized convergency. And on the other hand, in terms of throughput, our FAQ perform better than the other. And when you look at the FASTRA, the throughput is lower, and that is more stable because that one basically rely on the 4 input parameter. Okay, so next one is the network throughput compared to FAQ and the FASTRA, and with the increasing the number of vehicles. So as you can see, even though we are increasing the number of vehicles in the network, FAQ still perform much higher throughput compared to the FASTRA. So the next one, we like to look at the packet delivery ratio. So again, the same observation, our FAQ has higher PDF and compared to other, and very importantly, we can see that our FAQ will become more stable after 9 episodes. Okay, I believe that the last one is in terms of the spectrum efficiency. So the spectrum efficiency basically is to evaluate how much the simultaneous subchannel allocation to different vehicles at the same time. So you can see our FAQ give the higher spectrum efficiency. That means our FAQ will be able to allocate the same subchannel to many different vehicles at the same time in order to increase the system performance. And on the other hand, similarly, other DQN and Q learning also will not be able to be stabilized after many round of the training. Okay, so I think that's last slide. So again, for this one, we try to propose a novel reinforcement learning model to look at this V2X communication for the future 6G. So based on this observation, our combined fuzzy logic assisted Q learning will be able to dynamically allocate resource. So very importantly, the integration of the fuzzy logic into Q learning not only can speed up the learning process, but also can improve the learning outcome because the fuzzy logic can predict the instant reward for choosing a action, and the response learning can consider long-term reward of a allocation. So we have done a very extensive simulation using NS3, and the result demonstrate that our proposed FAQ perform better than the other. So yeah, so I think the future work will look at other communication in terms of this other different way of the UAV or the V2V. So I think, yeah, so I think I will finish this one. Sorry for this taking too long. Yeah, so I'm done. So
thank you, sir, for such an the token of our appreciation. Sir, can you stop your screen share?
Okay, sorry. Yeah.
Thank you.
Okay.
Thank you, sir, for being a part of this event, and we hope to see you soon again. Thank you so much.
Sure. Okay. Thank you.
Thank you, sir.
Okay. Thank you. Bye-bye.
It is a great privilege to have with us today Dr. Dinesh Bhatia, a distinguished expert
We are waiting for our session chair, Dr. Dinesh Bhatia, and then we will soon start the session. Please wait for 2 to 3 minutes.
Yeah, good afternoon to everyone.
Good afternoon, sir. How are you?
I'm fine, ma'am. How are you?
I'm fine, sir.
We can start the session now?
Yes, sir.
It is a great privilege to have with us today Dr. Dinesh Bhatia, a distinguished expert in biomechanics, rehabilitation engineering, and medical installation. I would like to call upon Shikha Bhatla to present a sampling to Dr. Dinesh Bhatia.
Welcome, sir.
Professor Bhatia holds a PhD in biomechanics and rehabilitation engineering from MNNIT Allahabad and has over 20 years of experience in teaching, research, and administration. He is currently a professor at the Department of Biomedical Engineering, Northeastern Hill University, Shillong, where he previously served as associate professor and head of department. He has received prestigious fellowship and awards, including the Young Scientist Award by Government of India, the INAE Fellowship, and ICMR Biomedical Research Fellowship at University of Glasgow, UK. He has also undertaken specialized training in Germany, Russia, and Malaysia. Professor Bhatia has authored 16 books, 40 book chapters, and over 400 research articles, along with multiple patents and funded projects focusing on assistive technology for physically challenged individuals. He currently heads the Entrepreneurship Development Center at NEHU and is actively involved in government committees, editorial boards, and professional societies. His research focuses on muscle mechanics, joint kinematics, medical informatics, and sustainable business models. With career dedicated to advancing biomedical science and innovation, his contributions continue to impact both the academia and industry. Welcome again, sir.
Thank you. Thanks a lot for the kind introduction.
So, now I would like to call paper presenter, paper ID 39, to present their paper.
Okay. This is Manish Gupta. I will pay the screen list.
So kindly show your iCard for verification.
Okay. Is iCard visible? Oh, okay. Let me change the background, I think. Okay. Is this visible?
Yes, sir, please continue.
Okay. Yeah, sure. So let me share the screen. Is my screen visible? Is my screen visible?
Yes, sir.
Okay. So we are presenting this paper, faster handwritten text line segmentation using customized fast video road for Marwari heritage script. So my Manish Gupta and my co-authors are Siddharth Dhawan and Ms. Lakshmi Panath from CDEC Pune. So here actually in this paper, why we did this, I just give you a brief background because for Marwari, there is no font, only handwritten manuscripts are there. So we have to digitize these manuscripts and we have to revive and proliferate the Marwari language. So we start studying that and we developed a font. And meanwhile, there is a requirement to create the offline handwritten recognition. So for that, this text line segmentation method is needed. So we explore it and we get the good result. Then after that, we publish the paper. So in this, basically, we are segmenting the handwritten lines. And Marwari scripts is mostly handwritten. A lot of complex characters are there. And it is connected also. And when I showcase you the sample image, you will be able to correlate. So for that, we use image processing and deep learning technique for line segmentation. Experimental results show superior performance compared to existing methods and contributing effective segmentation for long and interconnected word. So we first studied why it is needed and what are the challenges. So already ligature variation, diverse handwriting style and stroke formation, these were very difficult. So we searched for the already available text line segmentation for handwritten. We explored the method, tried to do it, but they were not working. Some new things need to be developed. So we reviewed the papers related to this, and due to limitation of heuristic-based and handcrafted feature method, they were not working in this. So we think we should try deep learning-based new method that is close to the handwritten recognition, handwritten segmentation. So we did the literature survey of this paper. And after that, we created the data set using Label Me tool. So this is the script that look like. You can see all words are connected. They are not straight line. They are overlapping. So we manually marked initially for 100 images and try to see the result after training. Then we see your system is learning something. So we created 375 annotated image data set, 300 for training and 75 for testing. So for this, we use this reference paper 25 first. How this is working. This was working quite, we can say 50 to 60%, not more than that. So we use this, inspired the network. We use this network, and inspired from this network, we designed our architecture. The backbone network with searchable blocks and feature extraction and upsampling to generate the final text kernel map. And here also we have to keep, like, our method should be having the good speed. Otherwise, there is no use of it. So for that, we use efficient TextNet to design real-time segmentation and utilizes proxylessness as this guiding framework for efficient search that is focusing on optimizing architecture search for text segmentation. In each stage, stride to convolution is used. Stride to convolution means filter moves by 2 pixels at each step. So this reduces the spatial dimension of the feature map while preserving key features. And then LI searchable blocks with 3x3 convolution for feature map reduction. And then searchable block have 4 operations: convolution 3x3, 1x3, and 3x1. Then use reparameterizable convolutions, improve efficiency in deployment. And importance of searchable block, this enhanced detection of elongated and rotated text also. And identity operation helps control network depth and speed. With L1, L2, L3, and L4 searchable block, this search space have 4 power L possibilities. So overall, this network is very good, and time is also very less in this. So we customize the reward for this also. In this, we used Internet over Onion for text kernel and text region also. And for inference speed on GPU, we use batch size 1 so that we can get the maximum FPS and get the desired inference speed. For this, weighted parameter uses 0.1. In this reparameterizable asymmetric convolution, improve feature extraction of rotated elongated text. This is this property of this asymmetric convolution. Not unlike traditional NAS method use MB convolution, this approach considers geometric attribute of text, and they were not GP efficient for real-time processing. Custom reward function optimized for text segmentation rather than generic object detection. The framework extends proxylessness for text detection. So in this feature research, should the search algorithm be redesigned specifically for text segmentation? Of course, yes. So in this, we use this dice loss. Dice loss is a metric that measures how well a predicted image segmentation matches a targeted image segmentation. So this is a sample we can see. We get the input image in the left side, then fast output is there. Then we customize this fast with erosion function that is improving the accuracy because some lines were joining due to overlapping, but due to erosion function, we get the better result. So finally, we utilize this because F1 score improves from 0.89 to 0.94 for this. And for erosion, we use OpenCV on the binary images, and visual representation is shown here. And for training, we use 50 epochs. Polynomial learning rate is defined here, and dropout is 0.1. And for this, we use CDEC, our own product, Param Shavak workstation that has NVIDIA Quadro GV100 GPU, 2.6 GHz Intel Xeon Gold, 96 GB RAM. And we compare this with existing text line detection method like DBNet++, that is working well in this printed text line segmentation. We have if we are using printed OCR, but for handwritten accuracy was very less. So we use this customize fast and then customize fast with post-processing. So we can see here recall, precision, and F1 score are improved in this. The proposed method achieves superior text segmentation for the Marwari script, and this customized pathway road improves segmentation accuracy, effective for long and interconnected work. Contribution enables further advancement in OCR for heritage. So here our main contribution is to showcase how we can use this line. So for future work, we should think of some method that is fully deep learning based. Here I use the fusion of deep learning and state-of-art method of erosion. So for future work, we have to enhance the robustness of overlapping and skewed text, eliminating reliance on erosion operation for post-processing, and expansion to the other low resource heritage script. And we will definitely try to create more data set, and after getting the more data set, we will train again the system, retrain the system. We will see how only deep learning method will work in this. And for this, we thanks Rajasthan State Archive, Department of Art and Culture for funding this project. So that's why we are able to do the research. Our phase 1 is completed and launched by the Rajasthan CM also, and now phase 2 is in process. Thank you, everyone. Any questions?
Yeah, thank you, Manish ji.
Yes.
And thanks for your wonderful work. We would like to know that what can be the limitations of your study?
So here actually this kind of work is never done till now for heritage text segmentation. This is the first time we developed the font. So now we are able to generate the data for offline handwritten recognition. But before doing that, we have to at least see how the mark image look like, so that we can enter the data for each line. You can see. Otherwise, here the problem is that who can read this Marwari, they cannot be able to type in Hindi or in Marwari. So we are creating the data like that. The Marwari people who can read, they are writing this meaning in Hindi. And after that, we are doing the data entry. But to align the data entry, this is very critical part. Text line segmentation should be perfect. So currently, our mostly 90% effort is reduced for manual marking. So now we are calling our algorithm, automatically generating the data as soon as we are getting the data set from that, so that we can start towards offline handwritten recognition. So this is very good work for reviving these heritage languages. And this we tried with Modi document also, and other heritage and tribal low resource languages. We are trying for that. We are getting good result. But due to lack of the data, I cannot show the result on that. And some copyright issues is already there, you know. Because finally we are doing it for accessibility, so that we can make all things accessible. Especially we don't know Marathi. Even Marwari people, Rajasthani people can't be able to read it. So when we make this accessible, this will proliferate Marwari language, and everybody will be able to refine it. Because in phase 1, we like bottleneck was no font was there. So we studied all these four types of zone is divided in Rajasthan. Jodhpur region alag, Bikaner region is different. So like that, totally 16 fonts should be developed, but we developed 2 fonts initially. Now we developed another 2 fonts. And in future, we will propose to Unicode, separate Unicode also. So for phase 1, last year we went there and did the workshop and for launching. But because these things was very good and prestigious, then Honorable State Minister did not launch it. They said it should be launched by the CM. Then CM launched this. So like learning tools, low resource languages, learning tools are required initially, and making deep learning algorithm or AI use, we have to develop the data. Like lot of data is there. If that is typed, then we can utilize this latest AI LLM model, even small language model, so that people start learning and get the answer, and researcher can do the research. So basically the main contribution right now started. Researcher can now tag this data and decipher the data and use in the research.
The number of images you have collected is 375.
375 we have annotated only.
Noted.
So that we can.
How many more images do you think you need for the entire 16 data set?
For actually, there are lakhs of pages are there. So initially they shared this data. This is their property. And soon when we start digitizing based on that, now algorithm will call on these lakhs of documents, but we do not take the data. We take the sample data only, and we will call our algorithm in their server only. We don't need data due to copyright and lot of things are there. So generally we take the sample data and algorithm development is there, and run the algorithm in their server and provide the access to them to validate and correct.
How you are overcoming the error? Because there may be what you say, some of the script is not readable or this thing, so it is not able to read. Then there might some error might creep. So how you are overcoming that?
So that's why I said we are working in this field. So we tried different image processing algorithm to try to contrast different things. Then somehow Erode was working in this kind of document, because finally we were getting this binary image. So you can see here you can see the lines are joining in a very lighter way, or we can show some other images. So when we see this, then we came to know that if we do something erosion or dilation, then there might be, we can segment these connected lines. Because handwritten, whenever we define this kind of text segmenter, they mostly the error is two lines are merged, kind of this thing. But here the accuracy of this algorithm is very good compared to the seeing the complexity. This is working fine. So I'm sure if we get the more data and more data is annotated, the accuracy will be improved.
Okay, thank you and success for your future work.
Yeah.
If there are any further questions from any of the participants, and we can invite then the next speaker. If there are any few more questions anybody wants to ask.
I believe the audience does not have any questions.
Yeah, so we can thank Dr. Manish, and we can invite the next. Yeah.
Now I would like to call presenter from the paper ID 52 to present their paper.
Hi.
Kindly show your ID card for verification. Thank you, sir. You may continue.
अभी चेंज कर दिया दिख रहा है क्या? तो मैं स्क्रीन शेयर करो, एक मिनट स्टॉप कर दूंगा. स्क्रीन विजिबल नहीं हो रही है ना? यही वाला कर दो कुछ प्रेजेंटेशन इधर ये कर देना. कंप्लीट एक्शन शेयर स्क्रीन विजिबल.
यस सूरज, इसको स्लाइड शो में कर दो.
Yes, it is visible now.
Okay. So good morning, everyone. Good afternoon, everyone. I'm Suraj Gade, and today I'm excited to present our work on FaceCom, a novel framework that identifies communities in group photograph using face recognitions and clustering. And this work was conducted at CDAC Pune in collaboration with my co-authors. And Kapil sir is my co-author, Kapil Mehrotra here. And just take an example, like in surveillance camera capture multiple suspect and associate in various locations instead of manually tracking who appears together. FaceCom can automatically reveals the connection between individuals and aiding the investigations. Now in next slide, here is the structure of my talk. First, I will introduce the problem. Then I will discuss prior research, explain our framework, and present our result, and conclude with the key takeaways and future directions. Now in introduction slide, as we know,
That is not changing.
change हो रहा ना?
नहीं हो रहा है. ये दिख रहा है. ये अभी स्पीड हुआ. कुछ और दिख रहा है मुझे. Stop sharing.
इंट्रोडक्शन स्लाइड दिख रही है सूरज?
Okay.
Okay. Now it is fine.
Okay. So in introduction slide, community detection is widely used in social networks, marketing, and surveillance. For example, companies like Facebook, LinkedIn use it to suggest friends or professional connections based on their common interactions. Facial recognition helps in security, identity verifications. It is like a fingerprint of a person's face, which is unique with respect to person. And our main goal is to bridge the gap using applying the community directions to group photo to uncover meaningful relationship instead of just identifying faces. We analyze how often people appears together to infer communities. So now in next slide, the prior research has explored the combining facial recognitions and community directions. For example, the first use CNN to clean mislabeled dataset, and the second one introduced the Adopt Infomap, a supervised face clustering framework. However, these methods mainly focused on single faces, not relationship in group images, and FaceCom fill this gap. Then in data preparations, we collected the 342 group photographs featuring politicians, celebrities, business professional, and sports figure. The goal was to create data set with real world diversity. Then we applied the image augmentations like blur, noise, and color jitter to make the model robust. For instance, security cameras often capture blurry images, so our data set includes such variations for better performance. Then we will move to the third slide. This is how our main data look like for the community directions for our framework. Then in next slide, we have the proposed frameworks. So in proposed framework, we had divided FaceCom framework into 4 parts. First one is facial feature extraction, then assign identities using clustering. All those things. I will explain the first step in next slide. So as you can see in above figure, we will get the idea of facial feature extraction in which we have 11.jpg. So we first use face detection to detect the faces in photos that will label person face like face serial ID plus image ID, so that we will have unique ID for each faces. Then we will extract the feature of face. Then in next slide, we have to assign the identities using face clustering. So after extracting the facial feature, the next step is to cluster the similar faces to ensure that the same person is consistently identified across the multiple images. This process called face clustering groups visually similar faces and assign the unique identity to individuals. Then we have tested multiple clustering algorithm.
Go ahead.
Suraj, your slide is not changing from introduction. Still, are you in introduction?
No, actually.
Stop.
Production slide here. Share.
शेयर तूने स्क्रीन करा है शेयर क्या
नहीं इतना किया है. Now is it visible?
Yes. Try to move next. Yeah. Now slide is moving. You can.
Okay. So I was on a facial feature extraction slide. Is this visible?
तुम्हारा क्या हो रहा है ये
Yes, yes.
Is it visible now?
Kapil, it is visible, but your notes are also displaying.
Okay. नोट जा रहा है
यहाँ से एक बार जूम से जाएंगे ना शेयर में शेयर अभी वाला स्लाइड शो दिख रहा है. So
ma'am, is it visible now?
the slide visible?
Yes, visible.
Go ahead.
Yeah, go ahead, please.
Okay. So as we were in a facial feature extraction, so in facial feature extraction, as you can see the images, in above images, the figure we will get the idea of facial feature extraction, in which we have the figure, we have 11.jpg. Then we first use face detections to detect the faces in group photos. Then we label the first person face using a face serial ID plus image ID, so that we can we will get the idea. We will get unique ID for each faces. Then we will extract the feature of faces. This is the facial feature extraction. Then after that, we are going to assign the identity using the face clustering. So after extracting the facial feature, the next step is to cluster the similar faces, ensure that the same person is consistently identifying across the multiple images. This process called face clustering. Clustering groups visually similar faces and assign the unique identity to each individuals. Then we have tested multiple clustering algorithm like k-means, dbScan, and InfoMap. Then we benchmark each clustering algorithm on standard dataset in which InfoMap outperforms. So in next slide,
excuse me, sir.
After that clustering done, we have to relabel the faces for identity consistency. So faces were initially labeled as serial ID, serial number, and image ID, but we converted them into the cluster-based ID. This makes identity tracking more accurate and ensures that all instances of the person are assigned to the same labels. This relabeling simplifies.
Sir, due to time, sorry to interrupt, sir. Due to time constraint, I would request you to kindly wind up in the next 5 minutes.
Okay, I will finish in 2 or 3 minutes. Okay. So this relabeling simplify community directions, allowing us to analyze relationship between individuals more effectively. Then we will move to the next slide, which is graph creations and weight assignment. So we construct a graph where each node represents the unique face and age represent how often two individuals appear together. the more frequently they co-occur, higher the age weight. So this weighted graph helps in detecting strong connections between the individuals, which is crucial for community detection in the next step. So after that, this is community detections. So this is community detection, and we applied the Girvan, Newman, and Lubin and Infomap community detections on this created graph, in which we find that Lubin algorithm, which is achieve the most modularity score, which is 0.93, and then after that Girvan, Newman, and after that Infomaps. So these are the results of our community detections, which is this is a community 1 of Bachchan family, this is community 2 of Ambani family, and this is Gandhi family. So this is what the result of our FACECOM framework. And this is the result and benchmark, in which we have main the So in which these benchmark of the clustering algorithms, in which there are K-means algorithms, then HACN, DBScan, and FACECOM algorithms, in which our Infomap clusters outperforms the state-of-the-art algorithms by 4 to 4.5%. And this is the graphical visualizations of the table. And the conclusion of our FACECOM effectively detect the community from the group photographs, outperform existing clustering methods. And the future enhancement in our community, in our framework, is that we have to scale this framework, and we have to find also overlapping community directions. This is the main conclusion of our framework. Thank you. Is there any questions? Hello.
Dinesh, sir.
Yes. So what algorithm you applied for feature extraction? Can you explain me again?
So we use our face rezero model to extract the facial feature, which is in-house built in CDAC.
Okay, and how you have tested it, that model?
On the standard data sets, like
we already have a face recognition system working. So we have trained it on 1 crore images, in which we have around 50 lakh subjects, and we have tried with resident architecture and the vision architecture as well, and we have applied various augmentations to it, and we have state-of-the-art accuracies on the various validations dataset like LFW, CALFW, CPLFW, and all those validation accuracies we have.
How much accuracy you are getting, sir?
Sir, accuracy depends on how much occlusion and other things as well. How much? So let's say for gender, we are getting, if you have a 20 years apart gender for two same subjects, so we are getting around 98% accuracy on that. The main challengeful data set is CALFW, on which we are getting 95% accuracy.
So what do you think could be the limitations? What do you think the things which could affect your future application and you need to address it?
Sir, main which we are targeting, we just wanted to build a proof of concept, because we are targeting this, because we work with various government agencies, and we are trying to implement this into their system. The main bottleneck which we are now founding is the surveillance cameras, because the feed which is coming from, actually this we have tried to think it for the cameras only, but we just now to build a proof of concept, so we have used it for images, whether this concept works or not. But now we can see it works. You can find the similar, you can find the people which are often seen in a photograph. But in surveillance camera, you have a very low resolution cameras. So we are currently working with the very low resolution VLR-FR, very low resolution face recognition. So that is a problem which we are now facing, which is the most which we are now trying to solve. So faces which are only have size faces which have only 30 by 30. So that is the problem, sir.
Okay, great. So any other participant want to ask any question to the speaker? Yeah, thank you. Then we can invite the next speaker if there are no questions.
Okay, sir. Thank you.
Thank you very much.
Hello, I'm Satvik Raga, and I'm presenting paper ID 90. This is my ID card. Is it visible?
Yes, sir. Thank you.
Yeah, go ahead.
Yes.
Sir, I would request you to present your
Can you
paper
inform?
within 10.
Yeah, how many presenters we have?
So we have 3 more. 4.
Sorry?
We have 5 more.
5 presenters. Okay.
Sir, is my screen visible?
Yes, it is visible.
Yeah. So, hello everyone. I'm Satvik Raghav, and along my co-authors are Vikyat and Raja Kartikeya and S. Lalita. And the paper we are about to present is called multi-speaker speech processing in noisy environments, a hybrid approach for speech separation and summarization. So we are from Amrita Vishwavidyapeetham, Bangalore. And let's get into why we came up with this. So I'm a final year student, and we were just taking notes in class. And that time I thought, what if we could build an automated note taking system? But I used some existing apps, and I figured out that when there was, in classes, there are discussions and there are noisy environments, that these note-taking apps didn't work. And even if you use the up and incoming technologies such as Gemini and other voice recognition, voice chatting softwares, when a lot of people speak together, as in you're in a crowded environment, this doesn't capture your voice particularly well. So we thought, why don't we work on audio source separation, and then we would look into the other aspects. So what we came up with is, we came up with a novel pathway actually that can separate audio, and this works well even in noisy circumstances. So existing models such as SepFormer and ContasNet exist, but as we shall know, that SepFormer is very good at separating audio, but in noisy environments, it doesn't perform well. As in, even if you have a slight background noise, as in any real environment, its performance actually decreases. And similarly, the other one, ContasNet, is good in noisy environments, but it struggles to separate audio completely. As in, if you separate, when two people are speaking together and you separate it, in one of the clips, you can still hear the other person and the vice versa. So, and also there are other highly computationally expensive models, which I don't think can run locally. And what we came up with is a proper pathway that first uses a SepFormer to initially separate the audio, and then using that separated audio, we process the ContasNet model on it. It's of course, SepFormer is a transformer-based model. It's a separating transformer, and ContasNet is a convolutional network. And we also added in a novel thing called adaptive noise reduction. And what this thing does is it of course reduces the background noise further, but it also enhances the prominent speaker's voice. For example, if my voice is the prominent speaker's voice, it enhances my words that I'm saying and all that. And then it looks to help in the other additional pipeline, which we have incorporated, which is summarizing and giving the summarized output. So we built subformer network, and it does exist, but we did it, and we use the WSJ data set for this. This is a compilation of the Wall Street Journal. You have two Wall Street, everybody knows the Wall Street Journal, and we had two presenters voice that was mixed, and that was the mixed audio sample on which this subformer model was trained. And the Libre 2 mix is trained on English audio recording, as in they read books, audio books, right? That audio recordings were mixed together. And here the additional parameter which was involved is noise, such as telephone sound or any white noises. These were added. So this is why ContestNet performs really well in noisy circumstances. But in subformer, it was a very ideal scenario, and there was no noise. And after this training, what we did was we were in our pipeline, whatever the noise, the audio we get, we first sample it to 8 kilohertz. Now you might say, why 8 kilohertz? Because we chose the perfect balance between efficiency and capturing how much ever we could, because if you do more, it might not, it might be computationally more expensive. And then we use normalization to ensure that all three models work concurrently. And then we used work well on the audio. And then we use chunking. This chunking is a specific process that is needed for convolutional networks such as the ContestNet. And as you can see here, this is our pipeline. And yes, this is our workflow diagram. First, we take in the audio, any regular audio, and then we resample it down to 8 kilohertz or up, and then we normalize and segment it. And then we extract features such as tone and all, and then we use multi-head attention. Multi-head attention essentially can work on various other chunks at a time. And then we use positional encoding. Positional encoding is important because any audio that we need to understand has a particular order associated with it. So this order is maintained by this positional encoding, and then masking is done to separate. And this is the first stage, the subformer stage. And further separation is done through the ContestNet. We used audio chunking here, as I said, dividing it into further smaller chunks. And then we do 1D convolution. This is the simplest convolution layer. And then we use a temporal convolution network. This temporal convolution network is essentially a CNN. CNN is mainly for images, convolutional neural networks. But this is temporal convolution neural network is a convolutional network is specifically trained for audio. And then the decoder, it reconstructs, and then we have a separated clips. And then these two, we worked on a 2-speaker. So the 2 speakers are then given to the adaptive noise reduction, which again reduces the noise more, and it gives more importance to the dominant speaker. And then you have 2 audio clips that has come in. And then we incorporated transcription, and we use the Google speech to text API for this. And then what it does is it gives a text form of the separated clip. And then we use a summarizer. We use the BART-based model, and that was trained on the CNN Daily Mail. And then it gives us summarized output of the separated clips. And what the features that are looked into here are the peaks, valleys, and all the transients. And then we use the temporal networks are captured by this model. And then we used adaptive. And these are the metrics that we got. We used signal to distortion ratio, signal to interference ratio, signal to artifacts ratio, and scale invariant SNR. These are all standardized metrics. Any and higher the better. And we have got respectable metrics, I would say. And now if we compare with the individual models, as you can see, the SIR, every model has this work has a better performance than individual models. So this combining worked. And also I would like to say that this particular order was important, as in first we use the subformer and then ContestNet. If you change the order, we observed that the performance greatly reduced. So this was the best order. Also, we did we looked at, we did a literature survey and we could see an AV subformer. An AV subformer is an audio visual subformer. This is a more complex part is of subformer, which it was implemented. But they include even the video, as in they look at even the lip movements of the speaker. And even though we achieved a higher PESQ score than them, and also existing work is the non-autoregressive speech separation, a NAS, and we achieved a higher SASNR than that model. And this is the waveform. As you can see, it's greatly, I would say, it's separated. And this is for speaker 1, and the noise is reduced, and this is for speaker 2. And yeah, for the transcription, we wanted, as I said, our main motivation was to create a separation notes making app of sorts. So we use the Google speech to text API, an extension of our work, and then we use the BART model for summarizing this. So for example, if I say come to our event where we discuss about how to improve power, and at this moment exactly the speaker 2 also starts speaking, I think we should have a reliable power network. So these two were essentially set together. But we can get a summarized output, separated and summarized output. First, we get this separated, as in what the speaker 1 spoke, what the speaker 2 spoke, and then a summarized output of what the discussion was about. So this can be used in any meeting scenario. And we tested our model based on our own voice samples we took from our own class. We had 2 people speaking. This model is based on 2 speakers, and we spoke in English, Hindi, and Kannada, and it worked for all the 3 languages. And yeah, so the key takeaway from this work is that this hybrid model works. It has a robust working. It works in noisy environments. All real life noises were taken into consideration. Phone noises, random background noise, all of them. And it greatly outperforms standalone models. And it also outperformed some of the more computationally expensive models, which even took video into consideration. And then we also had practical applications, such as you can use this in any meeting to summarize what the thing was. And future scope, I would say this was done on a single microphone, as in there was only one microphone in the room that captured the audio. We can use more microphones, and this can give a more spatial aspect. And also real time can be looked into, because this is not real time. You have to feed into the model, train it, and then you'll get back. So I think in the future, people can work on more real time, and also more multilingual and more accents can be looked into. We just took into very clear spoken language. We didn't go into the accents of people. So that can be considered in the future. Yeah. Thank you. Any questions?
Yes. What do you see the potential challenges of your software?
Yes, I think again we as I said, we only implemented on 2 speakers. So, but in the real world, obviously 5, 6, maybe 7. I don't know. It varies how many other people can speak together. So our model did not perform well in that. So it only can separate 2. So we need to work more on that.
Because noisy environment means, while if you are traveling or if you are in a public transport, then there also there will be many speakers who will be there.
Yes.
So the model has to work and try to control the noise, which is coming from different sources and different distances. Okay, so all those things need to be looked into it, and then the accuracy, the validity of the algorithm also has to be determined, whether it can filter out the noise and try to remove all those things. So that you need to work upon. It's a good start. I think you can improve it further by incorporating those changes and trying to make the model more robust.
Yes,
so this is from my side. If there are any further questions, the audience can feel free to ask. So if no questions, we can thank Satvik and we can invite the next speaker.
Okay, thank you.
Sir, can I present, sir?
Yeah, you can. I think you can present.
Yes, sir. So, is it visible?
Yes, you are good to go.
Thank you so much. Now I would like to call upon presenter from the paper ID 102 to present their paper.
Okay.
Kindly show your iCard for verification.
Excuse me. I think I am paper 102. I think. Could you?
Okay, you can go ahead then. Show your ID and please go ahead.
Okay. Is my ID visible?
Yeah, fine. Go ahead.
Okay. Let me share my screen. Am I audible?
Yes.
Okay. Is my slideshow visible?
Yes, it's visible.
Okay, thank you very much. So good afternoon, everybody. My name is Aikando. I'm from a graduate from North Carolina State University. Me along with my co-authors, Dr. Samit Kumar Ghosh from Khalifa University and Dr. R.N. Ponnalagu from BITS Pilani, Hyderabad, are presenting our work on a novel approach for estimating the diagnostic information loss from a fetal PCG signal during signal transmission. So in this paper, we introduce a novel methodology to estimate diagnostic information loss in fetal PCG signals during transmission. So PCG, fetal phonocardiogram, is a non-invasive technique to monitor fetal heart sounds, and it is crucial for prenatal health evaluation. However, and this particular PCG is a cost-effective method, and it offers a safe alternative to traditional techniques used like ultrasound and cardiotocography. So the FPC signal, it captures acoustic properties of fetal heartbeat. However, the diagnostic utility of PCG signals can be compromised during transmission due to various noise sources, signal degradation, and data compression techniques. So our our scope of engagement of this signal would be during with respect to pregnant women in rural areas who may lack adequate medical facilities to manage critical conditions, and telehealth systems serve they reduce the need for pregnant women in order to travel and visit medical centers in person. So in a telehealth monitoring system, PCG signal recorded from pregnant women are transmitted to nearby hospitals, facilitating immediate medical services. Such systems also enable continuous monitoring for fetal cardiac activity and fetal heart rate. So in order to acquire essential cardiac information, it must be recorded from the subject for an extended period. However, long duration PCG signals generate large amount of data which make data transmission challenging. Thus, it has to be compressed in order to establish efficient telecardiology system to provide adequate cardiac care. So researchers have previously developed various methods to compress signals across different dimensions. People like Hosni have introduced a biosignal compression method using Chebyshev moments. Daoi has proposed ECG compression techniques, and Agarwal and Ghosh have utilized DCT, DWT, and FWHT to achieve favorable results. So in this work, we are developing a novel methodology to estimate diagnostic information loss in fetal PCG signal use, and we are utilizing an ultra-wideband or a UWB transceiver for a signal transmission. We compare the performances of these three transformations which are utilized in the UWB transceiver, which are DCT, DWT, and FWHT. And finally, we evaluate the signal quality using multiple performance metrics. So to go into a little bit more detail, the compression techniques used are the discrete cosine transform, which is similar to the discrete Fourier transform, but we use real numbers, and discrete wavelet transform, where any wavelet transform are discretely sampled. And it's different from Fourier transform because it captures both frequency and temporal information. And finally, we have the fast Walsh-Hadamard transform, or FWHT. It is a divide and conquer algorithm which breaks down a Walsh-Hadamard transform of size n, and it uses recursive algorithms to break down a particular matrix. So we also use several the following encoding techniques, such as quantization, which maps the continuous FPCG signal to discrete output values, which simplifies the signal for transmission. Huffman encoding is employed to achieve a lossless data compression, which reduces the number of bits needed to transmit the FPCG signal, and it reduces data size and minimizing transmission time. And finally, convolutional encoding introduces redundancy to the transmitted data, thereby it provides noise immunity, and it also makes it highly efficient to correct errors during transmission. So similar to the above mentioned compression techniques, there is a decompression and decoding techniques which are highlighted, which are basically the inverse versions of the above mentioned three compression techniques: inverse DCT, inverse DWT, and inverse IFWHT. So this block diagram depicts the proposed FPCG signal transmission and reception system. So we have a pre-processing stage, and then we have a compression stage as mentioned in the previous slide. And then we have a UWB, the ultra-wideband transmitter, which ensures large channel capacity and low interference. It also contains multipath interference mitigation for improved signal integrity. So the transmission, in order to mitigate the interference, the transmission encountered additive white Gaussian noise, which is a common type of noise which affects the signal. It introduces a uniform noise spectrum which could degrade signal quality. Despite this, the UWB transmission combined with the brief-mentioned error correcting techniques ensures that the signal is accurately recovered at the receiver. First, we have a UWB receiver which amplifies and processes the transmitted signal. A low noise amplifier removes the noise and enhances the received signal. A pulse generator and integrator improves the SNR ratio and maximizes the signals. amplitude.
Sorry to
And
interrupt,
finally,
sir.
yes.
But due to time constraint, I would request you to wind up.
Yeah, please speed up.
within 2 minutes.
Okay, sure. So the following are the performance metrics. We have the bit error rate, which measures the error in transmission. The percentage root mean square difference evaluates signal distortion. The compression ratio indicates the efficiency of compression. And the quality score shows the trade-off between compression and quality. The mean square error shows the difference between the original and the reconstructed signals. And the signal to noise ratio it measures the signal clarity. And these are the relevant equations for the following metrics. So these are the 4 stages through which our signal goes. The first is the original fetal PCG signal. The second one is the compressed FPCG signal using the one of the transforms. And then we have the inverse version of the same transform. And finally, we have the reconstructed FPCG signal. So the data set was 26 signals from a public data set. And the results which we got was FWHT, the fast Walsh Hadamard transform, is able to outperform discrete cosine transform and discrete wavelet transform in compression ratio and signal quality, which indicates superior efficiency. We also have a performance table that compares the results. And as you can see from the results, the first Walsh Hadamard transform is outperforming DCT and DWT with respect to compression ratio and quality QS, which are the most important metrics. So I'm discussing the results here. The FWHT offers the better compression with minimal information loss. The high compression ratio ensures faster transmission, and it also maintains diagnostic integrity in remote fetal monitoring. So further improvements could include real-world noise simulations and clinical validations. So our limitation of the project are the following. We had our data sets only limited to 26 PCG signals. This could be expanded in the future. We could integrate real-world noise models into our given model. We could also take assistance from a clinical evaluation in order to validate from a diagnostic point of view. And in the future work, we also think about including advanced noise reduction techniques and clinical trials. So the conclusion is we developed a novel methodology to estimate diagnostic information loss in fetal PCG signals. The ultra-wideband UWB transceiver system ensures efficient signal transmission. The FWHT transform demonstrates superior compression and quality retention, and this has the potential to enhance the reliability of telehealth fetal monitoring systems. So thank you for attending my presentation, and I'm open to any questions.
Yeah, so what's the novelty of your work? Because a lot of work has already been done in fetal monitoring. So how it adds to existing knowledge?
Yes. So we have basically looked into the 3 compression studies, the transforms, which would be the false, the FWHT, which outperforms commercial solutions, which usually employ the discrete cosine transform and discrete wavelet transform. So these enhancements are able to improve the reliability and efficiency of remote fetal monitoring, which is sort of an alternative approach to existing telehealthcare systems. And it adds to existing knowledge as well.
Okay. So what do you think would be the limitations of your technique over the existing techniques which are available?
So currently the limitations of our study are, we have a somewhat relatively small data set of which is publicly obtained like 26 FPCG signals, and there's a sort of a lack of real world noise model simulations. And we could also improve our model with clinical validation. So if we expand our data set to include a larger and more diverse set of FPCG signal and include real world noise models, we would be able to address these limitations and improve our model.
Okay, thank you. No more questions from my side.
Thank you.
If any further questions, you can ask him. We can call the next speaker.
Yeah, stop sharing the screen.
Yeah, please.
Thank you, sir. I would like to call upon the next paper presenter, ID number 146, to present their paper.
Hello, sir. Is this the same last one?
Yes, sir.
Is this
so
the
kindly
last
show
one?
your ID card for verification.
Yes, sir.
I have digital ID, no PVC ID.
Please continue.
Is this the last for this session? Ma'am?
No, sir, there are two more. There are two more after that.
Okay. Okay, please ask them to stick to 5 minutes because I have some other engagement.
Okay, sir. Please limit your presentation to 10 minutes only.
Okay, ma'am. My screen is visual now. Hello. Yes, sir. It's visible. Yes, sir. Good afternoon to everyone. This is Shivaji Kanodia. I am a technical staff at IIT Kanpur. And my topic name is IFIR filter and filter bank designing using Sitorsky algorithm. These are the outlines, introduction, related work, methods, result and discussion, conclusions. Now I am starting from the introduction part. I am starting from filter. What is filter? Filter is used to remove the unwanted signal and depends on the frequency response. It is 4 types: low pass filter, high pass filter, band pass filter, band reject filter. In case of low pass filter, it is allowing low frequency. In case of HPF, it allow high frequency. And like that, band pass filter allow only a selected frequency. And in case of band reject filter, it allow only reject the certain frequency but allow the other frequency. And based on the implementation, it is 2 types. First one is analog, second one digital. And based on the characterization, it is 2 types. FIR filter, finite impulse response, and infinite impulse response. In case of finite impulse response, it depends on the previous input and the current input. But in case of IIR filter, infinite impulsive response, it depends on the previous output also. So it is the expanded form of the FIR filter. That's why I am starting from the filters and everything. Now, what is the filter bank? Filter bank splits the input signal into the multiple frequency band and depends on the splitting. It is mainly 3 types: uniform, non-uniform, quadrature. Uniform means equal division of frequency bands, and non-uniform, unequal, and quadrature a special kind of the filter banks. Now, discussing about QMF. QMF splits also split 2 channel, splits the frequency band into low and high frequency component, and it ensures minimum distortion and aliasing in the reconstruction. And non-uniform filter banks divides into the subbands into different breadth and the advantage and disadvantage of uniform and non-uniform bandwidth. In case of uniform, equal variable. In case of non-uniform, flexibility is low in case of uniform and high in case of non-uniform. Complexity lower in case of uniform, as shown in the figure as such. And application of a uniform filter bank is a standard filtering, and non-uniform adaptive signal processing. Now, related work is basically design on the filter bank design and optimization techniques. Different optimization techniques is used, and basically they are improving the computational efficiency, stop band attenuation, and aliasing reduction. These are the parameters the authors try to improve. And some key research contribution focus on CMFB, cosine modulator filter bank, and meta-heuristic and AI-based optimization, non-uniform and orthogonal. And next one is interpolated. These are the some works related to the filter banks, CMFB and hybrid filter bank, meta-heuristic. I explained already. So, but in this work, we are defining the methods related. Design the filter bank using the IFIR techniques. Then why we are using IFIR and what is the meaning of IFIR. So the meaning of IFIR means interpolated finite impulsive response. In case of FIR, the computational complexity is too high. So we are trying to reduce the complexity. We are interpolating. Interpolating means we are inserting some zeros in the samples. And one of the filter banks, MTR, near field reconstruction, is used to minimize the distortion. And in this optimization technique is used Sitowski algorithm, in which we firstly design the prototype filter. Parks-MacLean algorithm, and then compute the quadratic constant. It is used to minimize the stop band error. Stop band error should be less, and then optimize the filter coefficient by the sequential quadratic programming, and then apply the cosine modulation techniques for multi-channel. Now, IFIR filters, this is the filter model, provides the initial response, interpolation. In this slide, only we are increasing the what?
Sorry to interrupt you, sir. I would like to request you to wrap up quickly.
Okay, I am wrapping as soon as possible. If we are increasing the expansion factor by L, then the complex complexity or cost reduced by 1 by L. This is the use. And this is the M-channel filter bank. It is the composition of the analysis bank and synthesis bank. Suppose we have a signal XN. It is subdivides into M channels and deviated by M. At the analysis bank, deviation is used to reduce the length of the input signal, then deviates interpolated by M. Interpolated just inserting some samples, some zeros, M-1 zeros to the signal, and then pass through the synthesis bank filter. We are getting output signals YN. We are inserting the signal, inserting the samples due to the high reconstruction of signals. This is the optimization techniques, Sitowski algorithm, in which sequential quadratic programming is used. These are the optimization techniques. We firstly identified the number of bands, pass bands, and stop band frequency omega S, omega P, and then find out the filter length, and then find out the qualitative constraint. I am not going to explain every. I have not written every equation. I am just giving the overview of the equation. First equation telling about the construction and deconstruction of the signals, and second one is defining the interference, how interference is reduced, and last one is how to construct easily. Now, discussing about of results, in this we find out the amplitude distortion. Amplitude distortion means how much amplitude response of the signal is differ from the ideal filter. And second one is aliasing distortion. It measures the level of the indication of the interference. Third one is computational cost should be less. And fourth one is a peak reconstruction error. It is the difference between the peak maximum value of the response minus minimum value of the response. And last one is the computational time. It is the duration required to execute the program, in which in this work we define the four channel and 8 channel. This is the responses. We are getting amplitude response at minus 100 dB, and the aliasing error minus 100 dB, and in case of 8 channel minus 142 dB, and magnitude precision error 3.7, and amplitude error 9.5 into 10 to power minus 15. It is negligible in both cases. So it is designed for it achieved high stop band attenuation, aliasing distortion minimize, computational efficiency improves. These are the conclusions. High stop band attenuation minus 100 dB and 8 channel minus 142 dB we found, and reduce the aliasing distortion, improve computational efficiency. That's all about this. Any questions? I am audible?
Yeah.
Yes, you're audible.
Any limitations of the work you have? You can suggest what could be the limitations and how you can address it.
So limitations is a computational complexity. As we increase the number of the frequency, we cannot easily identify it. So we should minimize the interference and the aliasing error and stop band errors.
Okay, thank you.
Okay, thank you, sir. Thank you so much, sir. Now I would like to call presenter from the paper ID 233 to present their paper.
Okay, good afternoon, everyone. Am I audible?
Yes, ma'am.
Yes, you are.
Please show your ID card for verification.
So this is my ID card. Is it visible?
Yes.
Yes, thank you.
You can start your presentation.
Okay. So is the presentation visible? Hello. Am I audible?
Yes, you are audible. Please start.
So good afternoon, everyone.
Yes,
I'm
ma'am.
Reshma
Yes,
BS.
you're audible, ma'am.
Okay. Good afternoon, everyone. I'm Reshma BS. postgraduate student in VLSI and EMDA system at ER&DC Institute of Technology, CDAC, Trivandrum. It's an honor to present my research on tonal and temporal analysis of shockwave for multi-caliber ammunition at the 12th International Conference on Signal Processing and Integrated Networks. So today I will discuss how tonal and temporal analysis, combining these analysis, enhancing the firearm identification and caliber detection. Before going into the details, let's discuss the structure of my presentation. I will begin with the introduction and background, then followed by the methodology for gunshot signal acquisition. Then I discussed tonal and temporal analysis, the key temporal parameters of gunshot signals, and present our results, and finally conclude with the key takeaways and the significance of combining these analysis. So gunshot audio recordings can provide information about the shooter's location. That is, gunshot audio recordings contains the valuable information that determine to help the firearm type, caliber, and even the shooter's location. When a firearm is fired, two major acoustic events occur, that is the shockwave and the muzzle blast. Shockwave occurs when the bullet travels faster than the speed of sound, compresses the air molecules, and creates a high pressure Mach cone that propagates at the speed of sound. The shockwave propagates as a cone behind the bullet, traveling faster than the speed of sound, and its shape is an N-shaped pressure disturbance. On the other hand, muzzle blast forms when hot high pressure gas escape from the barrel. After that, a loud noise occurred, and that noise contains low and high frequency components. So the study of shockwave is more crucial in areas such as ballistic research, forensic science, and defense applications, etc. For analyzing the shockwave, the two major aspects are tonal analysis and temporal analysis. Tonal means frequency based and temporal means time based. So our objective is to combine.
Could you please come to your work done? Can you come directly to your work done?
Okay. We use a tetrahedral sensor array to collect these gunshot signals from assault rifle guns and light machine guns with tester calibers of 5.56 by 45 mm, 5.56 by 39, 7.62 by 39, and 7.62 by 51 mm. And the samples were collected across various environmental conditions, and the sensors are placed at 50 meter to 500 meter from the firing source. And we occurred more than 185 acoustic events, and the entire analysis is done in MATLAB software. So coming to the main point of my research. So first one is a tonal analysis. So tonal analysis mainly focus on the frequency content of the shockwave. So first, the analysis starts by first analyzing the gunshot signal and process it to obtain the shockwave, only the shockwave. And the spectrum of the shockwave is obtained using the frequency domain technique called fast Fourier transform. And from that shockwave spectrum, we got the peak frequency. And this table shows the details of peak frequencies from different weapons with different calibers, and this is used in different distances. So after recording the peak values for all these weapons, I generated a plot to illustrate the frequency versus range response. As you can see here, for all weapons, as you can see here, the shockwave frequency tends to decrease as the frequency increases, as the distance increases. So coming to the temporal analysis, here firstly I used a short time Fourier transform. Short time Fourier transform is an analysis for time frequency analysis that is used in non-stationary signals like shock waves. So the spectrogram that is plotted, that is seen in the lower plot on this figure, shows the indicates the concentration of energy in the specific frequency bands. So this energy diminishes over time, shows the energy dissipation as the wave propagates. It is found that most of the energy is concentrated at the lower frequency ranges, that is from 0 to 4 kilohertz. And this table shows the details of the time duration of the positive peak or shock wave, and this time duration is tabulated from the spectrogram. So this table shows the details of the time duration of positive peak or shock wave for an assault rifle at various distances. So this shows no trend. So we gone for extracting some of the key temporal parameters. So these are the key temporal parameters of gunshot signal, that is peak amplitude, it is a maximum positive value a waveform can reach, and peak time is the time at which peak amplitude occurs in a signal. Then rise time is the it's a time taken for a signal to increase from the lower percentage to its peak amplitude higher percentage. Decay time is the time taken for a signal to decay from the higher percentage. Yes.
Sorry to interrupt, ma'am, but due to time constraint, I would request you to wrap up quickly.
Okay. So this table shows the details of the extracted temporal parameters. So coming to the results, first part of our results focus on the donor analysis. So here, after analyzing the frequency components from these weapons, it shows that assault rifle 1 has the higher minimum frequency, assault rifle 3 has the widest frequency range, LMG 1 has the frequency pattern similar to assault rifle 2, and LMG 2 remains a steady frequency over distance.
Ma'am, can you quickly conclude, please? You're exceeding the time.
So for conclusion, by analyzing the tonal analysis, we came to know that smaller caliber shows higher frequency and larger caliber provides lower frequency range, and different weapons with same calibers exhibit frequency variations, possibly due to barrel length, muscle design, and internal mechanism. Also, assault rifles show wide frequency range than light machine guns. In temporal analysis, assault rifle 1 can be identified by the lower peak amplitude and lower decay time. Assault rifle 2 can be identified by higher peak amplitude and higher decay time. Assault rifle 3 can be identified by the wide range of frequency amplitude. LMG 1 and 2 can be identified by the moderate peak amplitude, also decreasing peak amplitude. And as a common trend shown here is that all the weapons have a consistent rise time, and overall the shockwave duration is 1 millisecond for all these weapons at various ranges. So the significance of combining these two analyses is that tonal analysis identifies based on the frequency pattern. Temporal analysis gives additional information based on this amplitude, rise time, and decay time. So both combining both these analysis gives the firearm identification accuracy. And for caliber differentiation, small calibers produce larger frequency while larger produce lower frequency. So temporal features helps confirm caliber differences. So thank you. So, do you have any questions? Hello?
Yes.
Thank you for your time, ma'am.
Yes.
Now I would like to call presenters from the paper ID 341 present their paper.
Yes, sir.
Please show your ID card first.
Sir, you are not visible.
Okay.
Thank you, sir. You may continue. Also, sir, I would like to request you to wrap up your presentation within 5 to 7 minutes.
What's your name? Show me again. Show your ID card, please.
Myself,
But it is Raja Subhasri M. The presenter is Raja Subhasri M. Your ID card.
See some issues, so I will present.
You're not audible. Say again.
Okay, ma'am.
Please show your ID card.
Ma'am, this is visible.
No, it is not visible. Visible yet? No. Okay,
Sir, I
present
think
your paper so that you can send your I card. Put. It is written Akash V.
Okay.
There is no.
Yes, ma'am.
But this paper doesn't have any author as Akash V. You're not the author. You're not one of the authors.
Yes, ma'am.
So how can you present?
Ma'am, we are also there is some issues, ma'am. So I will present.
Just wait for a second. I will confirm. Then wait for a second. Yes, please continue. Please share your screen.
Yes, ma'am.
And you have only 5 minutes. Please conclude your presentation in 5 minutes.
Okay,
Show your work.
Ma'am, myself Akash. I'm from the Chennai Institute of Technology. Our research paper is about RL-based control for cascader HPN 11 inverter.
Sorry again, the title that you are showing is not the same. Paper ID 341. The title is AI-driven optimization of a cascaded edge bridge.
Yes, ma'am. Same as same.
It's the same thing. Okay. That title is correct, right?
Yes, ma'am. Correct.
Okay. Okay. Continue, please.
Basically, the introduction about the basic of multi-level inverters. It was used to maintain high voltage levels and low harmonic torque. Distortion.
Please come to your work done. Please come to directly to your work done.
Okay. This is our proposed system. In traditional multi-level inverters, we have traditional methods. We can include this R-based algorithm. It was used to more efficiency compared to other traditional methods. You can see this one. With the RR algorithm, we can find the efficiency of 98%. Without RR algorithm, we can find the efficiency of 93%. With PI controls, nowadays we can use peripheral integrating controls. This efficiency is 95.2, and fuzzy control is efficiency is 96.5. Compared to other algorithms, with the RR algorithm, this gives more than efficiency than other algorithms. And this is analysis and diagrams. This is our implementation of our project. And this is the process. We can use the RL-based algorithm using the Arduino R3. You can see is the you can see Arduino R3 is used for generating the switching pulse, and we can use also TLP250 driver boards. It will efficiency to of lower voltage control signals with high power switching devices. And also we can use IR of 840 MOSFET. It is primarily used to DC to AC conversion. And this is how we get output. Output is in oscilloscope. This is a result in while simulating in the MATLAB software. The efficiency was improved by 98%. TKHD reduced to 2.45%, and it is contribute to sustainable goal development in SDG 7. And the conclusion based RL based control enhances efficiency and power quantity compared to other traditional algorithms. We can use future work implementation of DDPG and PPO or RL algorithms, testing in more dynamic environments. So, this one, thank you.
Thank you for your time, sir. That was the final presenter. Thank you. That was the final paper presenter. I would like to thank each paper presenter who presented their paper on their hard work. It was really a fruitful experience. I would now request Ms. Shikha Batla to present Dr. Dinesh Bhatia a certificate as a token of our appreciation for being the session chair. Thank you so much, sir. Your presence really lifted the entire session's experience.
Thank you. Thanks a lot. Yeah, thank you. Can I leave? Is it done?
Sir, just a second. We would like to present your certificate.
Yeah, please.
Thank you, sir. Thank you for joining the session.
Thank you. Thank you.
Thank you, sir.
I would like to request everyone who is attending this session to turn on their cameras for a group photo.
A very good evening to one and all. I, Apurva Shah, on behalf of the Department of Electronics and Communication Engineering, Amity School of Engineering and Technology, Amity University, Uttar Pradesh, feel honored to welcome you all on the first day of the 12th International Signal Processing and Integrated Networks Conference SPIN 2025. I also wish to extend a warm welcome to all the delegates and paper presenters presented here. It is our great privilege to have Dr. Justin Roberts with us today. I would like to invite Ms. Shikha Batra to present a sapling to Dr. Justin Dowles.
Welcome, sir.
Hello, good afternoon. Okay, should I share my
It is an
screen?
honor to introduce our esteemed speaker, Dr. Justin Dowles, a distinguished researcher in data analytics, intelligent transportation systems, and autonomous systems. Dr. Dowles is an associate professor at TU Delft in the Signals and Systems Group, Department of Microelectronics, and co-director of the Safety and Security Institute at TU Delft. He is also the scientific lead of the Model Driven Decision Lab MODDL, a pioneering collaboration between TU Delft and law enforcement agencies. Previously, he was an associate professor at Nanyang Technological University, NTU, Singapore, and has held research positions at MIT, ETH Zurich, and Reichenbach Science Institute. His groundbreaking work in predictive analytics, human behavior analysis, and forensic science has earned international recognition, including coverage by the BBC Straits Times and global media. Dr. Dowles has served in key leadership roles in IEEE, including chair of the IEEE CIS Singapore chapter and associate editor for IEEE transactions on signal processing. He is currently an IEEE SPS Distinguished Lecturer 2024 to 2025 and holds editorial positions in leading journals such as Elsevier Signal Processing and IEEE Signal Processing Magazine. Beyond academia, he actively collaborates with startups, SMEs, and MNCs in data driven transportation, logistics, and medical analytics. His research team has even spun off four successful startups in AI driven healthcare and autonomous vehicles. With a career dedicated to innovation and real world impact, Dr. Dowles continues to shape the future of AI, signal processing, and intelligent systems. Welcome once again, sir. We feel honored to have you grace SPIN 2025. Now, I would like to request Dr. Justin Dowles to present on his topic, Extreme Precipitation Nowcasting using Deep Generative Models.
Hello, good afternoon. Thank you for the very generous introduction. I hope you can see my slide. Oh, excuse me.
Yes.
So yes, okay. Please stop me if something goes wrong or you have a question. I cannot see you. I will just go ahead. So this is work based on work from multiple students, PhD students, Christian Mayo and Krishnoi, also some master students, Haran B, Junsei Yi, Zaina Busher, and Varun Chandran. And let me first explain why we are working on this problem. So as you know, flood disasters are becoming more common. There have been more than almost 5,000 flood disasters between 1999 and 2023 across the globe. Sorry, I'm trying to fix something here. I'm struggling with I can't see much of my screen actually at the moment. Okay. Okay. So across the globe, many lives have been lost, over 600,000 lives due to floods. And that number will only increase due to the more frequent floods. And some countries are more exposed to floods than others, especially Netherlands, where I'm living. Netherlands, part of the Netherlands lies below sea level. So for Netherlands, water management is of very high importance, and the risk of floods definitely is being monitored all the time. The same holds for Bangladesh and other countries, and to some extent also in India. If you look at the previous map, you can see India here. There's definitely also significant exposure to floods in India. looking at the financial losses due to all kinds of natural disasters. First of all, you can see that the losses have been increasing over the years, especially recent years, and also there is a significant fraction of the loss due to flooding. It's not the biggest source, so to speak, but it's definitely significant. Now, here's some information about the situation in India. So the India Meteorological Institute has declared prediction of extreme weather to be an to be a crucial topic, and they have reported in the National Climate Change Assessment Report that there has been a 0.7 degrees rise in surface air temperature over India from 1901 to 2018, and 1 degree Celsius increase in tropical Indian Ocean sea surface temperature from 1951 to 2015. Of course, the numbers are increasing in recent years. You might be aware, there's not what I wanted, aware of the floods in Delhi, New Delhi, last year, 2024, on June 28th. Such floods might become more frequent due to human-induced factors such as greenhouse gas emissions, aerosols, and use changes. Such factors have led to more climate extremes, and due to climate change, there's a higher frequency of highly localized extreme weather events such as extreme rainfall, leading to floods. So the IMD, Indian Meteorological Institute, has issued a warning on that same day, the 28th of June 2024, and a few hours later, then indeed the city woke up the highest rain it recorded since 1936. So it's a major event, extreme weather event. So our aim is to try to predict such extreme events reliably in advance. Now, extreme weather events have effects on the horticulture in India. And here's some data from northern India. So fruit crops, for instance, are vulnerable to climate change with disruption in flowering and fruit set and ripening due to warmer winters, the rainfall, extreme weather events. So in the north of India, Uttarakhand, there has been a steep decline in fruit cultivation, with the area under cultivation dropping by 54%, and also there's a decrease in the yields, fruit yields by 44%. So you can see that also in the graphs below. You see the fruit yields in the past in blue, 2016 to 2017, and in orange, 2022-23. You see that the yield has dropped significantly, unfortunately, and also the area and the fruit production has decreased. So same, you can see a drop. So the orange bars are far smaller than the blue bars. The blue bars corresponding to the fruit production in hectares 2016 to 2017. So our aim, as I mentioned, is to predict extreme weather events, particular rainfall. Now you have to make a distinction between forecasting and nowcasting. Forecasting is about predictions made about weather patterns over several days or weeks, even months. But extreme rainfall events should be forecast sooner so that people can take precautions. Nowcasting is it's about short-term prediction. Actually, it's about prediction over a time span of a few hours, say 3 to 4 to 5 hours, but not beyond that. So certainly not on the scale of days. So it's nowcasting means a very short-term prediction on the scale of hours, and that's exactly what we're trying to do. That is usually done based on data and less based on models, not based on physics models. Before I dive into nowcasting, I would like to say a few words about numerical weather prediction models, which are currently used for forecasting over, as I mentioned, days, weeks. So that relies on mathematical equations that describe the atmosphere, the dynamics in the atmosphere, as shown on the right. You can see there some typical processes. And for instance, these equations, so these mathematical dynamics describe for instance, moisture, how moisture is conserved. So they have the moisture compensation equation. That's part of such models. Now, the good news is that numerical weather prediction has been improving a lot. I don't know if you've noticed this over the years, the last decades, I should say. So the forecast skill has improved significantly. You can see that in the top figure. You see how the forecast skill has increased over the last 3 to 4 decades. That's due to a number of advances. First of all, scientific advances, meaning that people have now better kinds of models, like ensemble models, as shown in the bottom graph, where you can make multiple predictions and then combine them. So you can actually have an estimate of the probability of rainfall. So you don't make one prediction, you actually make many different predictions, and you look at the overall ensemble of predictions. That's a scientific improvement. Also, now in general, there are more sensors, more observations being made using different technologies, satellites and radar, and weather stations, etc. And also the computational power, is improved, has been improving. Now we have more powerful computers, and that combined with a better availability of data and the better modeling tools, that has led to improvements, significant improvement in the numerical weather predictions. And now, as I said, we have to make a distinction between NWP, numerical weather prediction, because that's usually in the range of 1 to 10 days, whereas we care about nowcasting, because there's much shorter range of a few hours. And the benchmark, so to speak, what is now being used oftentimes is the open source Python platform, PySteps, which is freely available as open source. You can actually try it yourself if you want to. And that is being used in the Netherlands by the Royal Netherlands Meteorological Institute as its operational nowcasting system. This seems to work reasonably well, but it's not designed to predict extremes. So it predicts what could happen on average, but it's not designed to specifically target extreme rainfall. Without going into too much detail, but PySteps is based on optical flow and also makes use of extrapolation techniques. So it looks at the motion field of the clouds, for instance, or mainly the clouds, and then tries to extrapolate that motion fields to the future. And so it has a spectral prognosis part, which is a deterministic approach. It also has a probabilistic formulation in there called STEPS, short-term ensemble prediction system, which I referred to earlier. Ensemble meaning you can make multiple predictions in parallel. So it has those two components, a deterministic one and a probabilistic one. Now, I talk about NWP and how it became better over the last years. That's actually not even including AI. So that improvement I was talking about is pre-AI. It's happened before AI came to the scene. And now with AI, people expect further improvements. And as an illustration on the right, you can see predictions. These are short-term predictions, nowcasting predictions. And you can see predictions, well, see at the top, first row are the actual conditions. You see predictions using different machine learning methods. And at the bottom, you see kind of an advanced model, how it predicts. So it seems to be doing a reasonable job. So deep learning is making strides in this field of nowcasting. So many groups are looking into how to use deep learning for nowcasting purposes, including, of course, our group at TU Delft. And it's not just academia that is interested in this problem. Also, some big tech companies are involved. So DeepMind has released a deep generative model for radar, 2021, which kind of stimulated the field to look into deep learning for such applications. So it was a kind of a pioneering paper. And now many groups are looking at the same approach or similar approaches, so using deep generative models. Also, Microsoft has released 2 years ago a model, vision transformer-based model But then there are also many other models in academia. So I just mentioned one of them here from our group at the bottom of the list. That has become a very active field, and it's interesting that also big tech companies are getting involved. Now, we'd like to say a few words about how we develop models. What are the ingredients? How do we do it? I will not, of course, go into all details because there's not much time. I'll just highlight some aspects. So look at this as a kind of a triangle. So we have three different aspects to our models. The first is that we use a neural architecture. In fact, it's a GPT model, like in language models. In fact, we use the Llama model. Recently, we've been starting to use the Llama model Meta, Llama 2, which is normally used for language models, but it also can be used for weather prediction, which may seem a bit strange, but I will try to explain how that may actually make sense. So you have the first corner, so to speak, of the triangle. That is the neural architecture. The second aspect is extreme value theory. Indeed, we try to predict extremes, and if you're not careful, the model will only predict average behavior, but we want to push it in a way that it actually tries to predict extremes. So we have to incorporate some elements from extreme value theory. Number three, of course, we're predicting a physical process, weather, rainfall. So we have to include physics. So we have those three different elements that have to somehow converge. And so we work on those three aspects in our team. So just a few words about the neural architecture. Neural architecture, so somebody came in the room. Excuse me. So it's basically a transformer model, as it's used also in language models. And I will say a few words about the way we approach it. In fact, what we do is we have a code book. So it's a collection of patterns we learn from data. So we divide each image into small patches, and then compare each patch to a dictionary of patches that we have stored, we have optimized. And then we find the nearest, the most similar patch in the codebook. So each patch of an image is matched to a pattern in our codebook. And so that these patterns in the codebook are actually kind of symbols, because we have a finite number, each has a number, right? So each image is decomposed in patches. Each patch corresponds to a pattern in the codebook, is matched to a pattern in the codebook. That's how we, in fact, transform the image into a sequence of symbols. And now when we predict, we actually predict from multiple images from the past. Say maybe you go back 1 hour or 2 hours to make a prediction. Then we have, say, 10 images. Each image is a sequence. So we have actually a sequence of sequences. So we end up with a long sequence of symbols. And then we use that to make a prediction. So we try to extend the sequence, try to predict what will follow upon that sequence, and then we transform that sequence back into an image. So we then, reconstruct the image patch by patch, and that's how we make predictions. So there are two parts: the auto-regressive transformer, like in the language model, that predicts how to extend the sequence, input sequence, and then we have the code books where we use a vector quantized variational autoencoder that allow us to map, I should say, an image into a sequence of symbols. So here you see a little bit in action. Say you have three input images from the past, or the current one at time t, xt, xt minus 1, xt minus 2. Use those three to make predictions in the future. But here we see actually the encoding process. So we map, as I mentioned, each image into sequences. The blue squares in the middle correspond to the symbols, and then the decoding part on the right. So once you have made the prediction of symbols, you match those symbols back into images that is shown on the right side. That's a decoding process. Here's a slide about the autoregressive transformer. That's the exact same engine as you have in language models. And yeah, I won't say much more about that, but it's just extending or predicting what follows upon a sequence. What's going to be the next symbols in a sequence. It's a bit like in language. You see first half of a sentence, we'd like to predict the end of the sentence. So it's kind of similar. But now, of course, each symbol corresponds to a patch in the image, not a language symbol or word. So this is the architecture, nowcasting GPT architecture. So that's very similar to a language model, as I discussed. You see how it's being encoded and decoded. And so we take 3 input images and then we predict 6 output images. So we go 6 steps into the future. That was, in a nutshell, the neural architecture. Again, heavily inspired by language models. In fact, in the current work, we use the Llama 2 model of Meta. Of course, we train it with our application, but the architecture is from Llama 2. Now, physics. How do we incorporate physics? I've talked briefly about the moisture conversation equation. We would like to use that. We would like to make sure that our predictions fulfill such equations. So how can we achieve that? So how do we make sure that the predictions coming from this nowcasting GPT model are physically plausible? For that, we add losses into the system. So we have a loss function that contains terms from the VAE, the VQ VAE, vector quantized VAE. But we add terms, loss functions, that make sure that we try to encourage the nowcasting GPT model to predict physically plausible patterns. And for that, we construct a GAN, generative adversarial network, that makes sure that, or checks how physically plausible the predictions are. And if they're not plausible, there will be a high cost for that. And just to illustrate that a little bit, so we have the Morse equation here on the right side, and that in principle, in theory, should be 0. So R is like how much it deviates from 0. And we check how R looks like for real patterns and for predicted patterns. So we give the signal R to the GAN, and then, in fact, we don't give R, but eta k, this exponential minus lambda rk, that we give to the GAN as an extra signal, and then it will check this signal eta k of real images and of predictions. It will try to make sure that the patterns in eta k for the predictions are similar to the ones for the actual images, actual data, radar images. At last, extreme value theory. We try to predict extremes. And so we incorporate one more loss. It's the extreme value loss that encourages the model, the nowcasting GPT model, or to predict extremes. So we tolerate false positives, but we want to make sure that it predicts extremes, so we don't penalize too much the false positives. That you can see on the right side, you have diagrams showing that compared to the regular cross-entropy loss, this EVL loss penalizes the false positives less. So you can see that on the right side, the red curve actually lies below the blue curve, but I won't go into details. That's kind of the gist of it. So you have those elements taken together. So the physics-informed approach combined with extreme value loss, and at the core we have a nowcasting engine. We'd like to briefly show some results and then end. So we have results for a dozen catchments in Netherlands. Catchments are areas where lots of water is being accumulated. They're like natural bassins in the landscape where water is being collected naturally. And we define the extreme events as cases where there's rainfall of 5 millimeters or more over a time span of 3 hours. These are defined as extreme cases, extreme rainfall events. And we investigate those cases, those events across those 12 different catchments. We compare different models. PySteps is our benchmark, one that is being used in practice. and we compare with a few of our models. Nowcasting GPT, which only has the neural part, the neural architecture without physics, without extreme value. So if you do that, if you look at that model, it has actually high precision compared to PySteps. It's more capable of detecting the extreme cases. The other model is one that takes into account also extreme cases. So this is a bit more complicated, but we see here different combinations of models, of our models. I will not go into details, but the blue line is from PySteps, the benchmark. You see that our models are better able to detect the extremes. We have done an ablation study where we take the overall model, we switch up different parts of it. So we switch up physics, we switch up extreme value loss, etc., or both physics and extreme value loss. We see that in any of those cases still it performs better than PySteps. It's when you combine all of it together that you have the best results and the highest precision. So, in summary, in our work, and this is of course work in progress, there's still much to be explored. We take three different elements and put it together. There's the neural architecture, there's making the predictions, which is inspired by language models, and we bias such models towards physics. We encourage the models to predict physically plausible patterns, and we also encourage the models to predict extremes, because if we don't do that, it will just try to predict the average behavior. You will miss the extremes. Now, what's on our agenda for the next months and years is to look into the data with higher temporal resolution. Now we have an image every half an hour. We'd like to use higher resolution data, which has an image every 10 minutes. We would like to also apply our model to the whole stack of images in one step, namely by using three-dimensional convolutions as opposed to two-dimensional convolutions, and also to further explore physics constraints. We have included only the moisture equation. There's still many things that can be done. Different types of equations can be incorporated. Even the moisture equation can be analyzed at different heights, for instance. So that's something we should further explore. So with that, I would like to end, and I'm very happy to take any questions.
I have a question. I mean, I've seen that your model basically predicts the temperatures or the precipitation events over a certain country, I guess the Netherlands in this case. So how do you factor in weather conditions from like outside the particular area? Like, for example, if you look over Florida, the hurricanes come from the south, so they might be like a surprising kind of a factor. So how do you factor that in your model?
Yeah, at this point, we don't factor into our model because we have limited compute power, and we would have to model a wider area, but it's just not feasible with our limited number of GPUs. So that's a major constraint. We have to limit ourselves to a more localized area, number one. Number two, we only take data every half an hour. We don't use all the radar images. So that's a major constraint. But in principle, we should be looking at a larger area, indeed, including Germany and France, Belgium, neighboring countries, North Sea, etc. Yes.
Mm-hmm. Thank you.
And yeah, by the way, we are in discussions with the AMD, at least colleagues of us in India are having discussions with the Indian meteorological departments, and they seem to be willing to share data with us. Then I can look at a place like Mumbai or Delhi to make such predictions. So nowcasting predictions. That's also one of the things we want to do, to, of course, apply this methodology beyond the Netherlands, also in the US, Singapore, India.
Yeah, I guess I have one more question. So, do you face any issues getting data sets from different regions, which may have issues having like measurement issues, like maybe poorer countries like Africa may have a lesser measurement constraints or something like that?
Yes, in Africa, there's definitely constraints. I'm not sure about India, but Africa, yes. I have a colleague of mine here at the TU Delft who has pioneered a technology to measure precipitation from energy signals collected at base stations, so base stations of communications networks. And so for mobile networks, so the signals that are received at base stations are weaker when it's raining. So rain correlates somehow with the power in the signal at base stations. So that's an indirect measure of rainfall. It can be acquired in places where there's no radar coverage, where there are no weather stations. So that's it's called passive measurement of precipitation. That's being tested in certain African countries, also in Sri Lanka.
Okay.
And we had the idea, we had put together a proposal to do the same in India. Unfortunately, the proposal was not accepted, but it's something we want to try in the future, to do the same thing in India.
Yeah, I guess that's an example of data imputation. Oh. Okay, thank you.
Yep.
Thank you, sir, for sharing your knowledgeable words. Now, I invite Ms. Shika Batla to present a certificate to Dr. Justin Roberts as a token of our appreciation. Sir, please can you turn off your screen sharing? Thank you, sir.
Okay, thank you very much. Yeah.
Thank you for being part of this event.
My pleasure.
Thank you once again.
Thank you,
Pleasure, thank you.
everyone. Yes, sir.
Hello. I was just saying thank you for your questions, and looking forward to giving a talk next time as well.
Thank you, sir. Thank you, everyone, for being a part of SPIN 2025. We will resume the sessions tomorrow. Thank you.
Thank you. Thank you very much.